f of 5 plus x equal to f of 5 minus x for every real value of x. F of x equal to 0 has 4 distinct real roots. Then the sum of these roots is a wonderful question. Right? So I tried some algebraic methods of solving it and then went nowhere with it. Right? F of 5 plus x equals f of 5 minus x. And so think about this. We draw the graph. F of 5 plus x is equal to f of 5 minus x. So f of 6 is f of 4. So we have 6 and 4. F of 7 is equal to f of 3. 7 and 3. If f of 6 were here, f of 4 would be here. F of 7 were here, f of 3 would be here. Whatever value in between, it will be like that. So some curve like this, some curve like this, some curve like this. It's going to be a graph. You can imagine a graph like that. Right? So I just want to dwell on this. I tried this, but then it didn't take me anywhere. It looks like it is symmetric around 5. Yeah, so what? And it has 4 distinct real roots. So let's break this framework. Let's assume that it cuts somewhere here and then cuts somewhere here. 2 roots. Therefore, it will cut here and cut here. 4 roots. Now we are on to something. There are 4 roots. Think about it. If f of 12 were 0, assume that 12 is a root. That means f of 5 plus 7 is a root. That means f of 5 minus 7 should also be a root. F of minus 2 should be a root. From 5, if you move some number of units to get a root, you should move the same number of units this side to get another root. Now we are on to something. So navigating from 5, this side if there is a root, that side there is a root. Maybe you navigate 7, maybe you navigate 12, maybe you navigate 15. Forget that. Idea here, suppose this and this are roots. If you add these two, they'll be of the form 5 plus k and 5 minus k. 5 plus k plus 5 minus k is 10. Roots come in pairs. Sum of any one pair is 10. There are 4 roots, 2 pairs, 20. The roots have to be of the form 5 plus k and 5 minus k. They have to come in pairs. 5 plus k plus 5 minus k is 10. 2 such pairs, 20. Log 5 to the base 4 equals log y to the base 4 times log root 5 to the base 6. Take this side, we are through. Log 5 to the base 4 by log y to the base 4. This is nothing but log 5 to the base y. This is log root 5 to the base 6. Let's call this as k. 6 power k is root 5. Y power k is 5. Square this. 6 power k is root 5. 6 power k whole square is 5. Y power k is 5, which is nothing but 6 power k the whole square. Or this is 36 power k is 5, which is nothing but y power k, or y equals 36. Log root 5 to the base 6 is same as log 5 to the base 36. The number of real valued solutions to the equation 2 power x plus 2 power minus x is 2 minus x minus 2 whole square. Beautiful question. You think about this. 2 power x and 2 power minus x are both positive. Fine. The minimum value this can take, this is of the form y plus 1 by y. The minimum value it can take is greater than or equal to 2. If it were negative, it will be less than or equal to minus 2. If it is positive, it is greater than or equal to 2. So this side is greater than or equal to 2. This side, this is greater than or equal to 0. Or this part is less than or equal to 2. From 2, you're subtracting a non-negative number. The maximum value the expression can be is 2. We're done. This has to be greater than or equal to 2. That has to be less than or equal to 2. The only possibility is if both are equal to 2. Be equal to 2 when x is 0. Put x equal to 0. 2 power 0 plus 2 power minus 0. This is 2. But if you put x equal to 2 here, we get 2 minus, x equal to 0 here, 2 minus minus 2 square, 2 minus 4 equal to minus 2. It doesn't work. This will go to 0 when x is 2. At that time, this is not 0. So there's no case where this is equal to 2 and this is equal to 2, or we'll have 0 real valued solutions to this. X equals 4096 to the power 7 plus 4 root 3. Which of the following equals 64? Now there's a bunch of things where being numerically comfortable is very helpful. 64 square is 4096. This is 2 power 6. This is 2 power 12. That is helpful. So this square root idea involved here somewhere. And so x can be written as 64 square whole power 7 plus 4 root 3. Wonderful. So that could be helpful. Fine. The second thing, which of the following equals 64? So we still don't know how to get to 64 from here. And so we can say square root of x is 64 to the power 7 plus 4 root 3. Or square root of x to the power 1 by 7 plus 4 root 3 is 64. 1 by 7 plus 4 root 3. 7 plus 4 root 3 is a beautiful number. 7 plus 4 root 3 into 7 minus 4 root 3 is 7 square 49 minus 16 into 3 48, which is 1. The reciprocal of 7 plus 4 root 3 is 7 minus 4 root 3. Or square root of x to the power 7 minus 4 root 3 is 64. How do we get there? Okay, this is x power 7 by 2 by x power 4 by 3. This is x power 7 by 2 minus 4 by root 3. Sorry, it should be 4 root 3. It's given incorrect. It should be 4 root 3. No, 4 by root 3. 4 by root 3. That doesn't work. 4 by root 3. It's tough to reconcile. This is x power 7 minus 4 root 3. This is also incorrect. It will be square root of x power 7 minus 4 root 3. This is x power 7 by 2 minus 2 root 3. Yep. This is x power 1 by 2 whole power 7 minus 4 root 3. This choice works brilliantly. Choice A, if it had been 4 root 3, we would have exploded. It is 4 by root 3. So we don't have to worry about it. Choice C takes us to 7 x power 7 by 2 minus 2 root 3, or x power half whole power 7 minus 4 root 3. Numerical friendliness, being friendly with picking that 7 plus 4 root 3 and 7 minus 4 root 3 are reciprocals. 4096 is 64 square. That really pays off. So it's a cruel question if you can't pick that. X plus 1 by x the whole square minus 3 times x plus 1 by x plus 2 equal to 0. Simple. Let's say x plus 1 by x equal to y. Y square minus 3y plus 2 equal to 0. Remember, y is greater than or equal to 2 or y is less than or equal to minus 2. Anything of the form x plus 1 by x, you should know this again. This is y minus 1 into y minus 2 equals 0. Y is 1 or 2. Y cannot be 1. X plus 1 by x cannot be 1. So y has to be 2. X plus 1 by x equal to 2 has x plus 1 by x equal to 2 has only one solution, x equal to 1, or this has one real solution. X square minus 7x plus 11 whole power x square minus 13x plus 42 is 1. Sounds like an incredibly tough question. But think about this. Any number power 0 is 11. So this could go to 0. Fine. If you have a number 1.6 over anything apart from 0, it cannot be 1, because if it's 1.6 power positive number, it will keep going higher and higher. Negative number will keep going less than 1. It can be equal to 1 only if it were 0, or the only time a non-zero power can give us 1 is 1 power something is 1. It's very simple. So x square minus 13x plus 42 equal to 0, or x square minus 7x plus 11 equal to 1. Solve these two, you're good to go. X minus 6 into x minus 7 is 0. 6 or 7. You need to substitute that to verify, but in both cases it's going to be some integer. We can even say it will be a positive integer. So 36 minus 42 plus 11, yeah, positive. Nothing to worry. Substituting works. Or here we have x square minus 7x plus 10 equal to 0. X minus 2 into x minus 5 equal to 0. X is 2 or 5. You put 2 or 5. You put 2. 2 square minus 26 plus 42. Again, nice positive integer. Nothing to worry. You put 5. Also will get a positive integer. Nothing to worry. 2, 5, 6, 7. All of these work. 4 values. Hang on. There's one thing we have missed completely. We can even get 1 as minus 1 per an even number will give us 1. We'll have to verify that. How do you verify that? X square minus 7x plus 11 equals minus 1. X square minus 7x plus 12 equal to 0. X minus 3 into x minus 4 is 0. X could be 3 or 4. Minus 3 power, if you put x is 3, minus 1 power, some number, could be 1 if that power is even. So put x is 3, 9 minus 39 plus 42. 9 minus 39 is minus 30 plus 42. This is 12. So x equal to 3 works. Put x equal to 4. That will definitely work. 16 minus 13 into 4, 52 plus 42. 16 minus 10, this is 6. That's also an even number. We get minus 1 per 6. So 3, 4 could work as well. So 2 and 5 could work. 6 and 7 could work. 3 and 4 could work. Or there are 6 possible values. I missed this one and I got 4. Because I completely forgot the minus 1 per 4 thing. So beautiful question. You'll have to worry about this going to 0. This going to plus 1. This going to minus 1 in the time when this is an even number. The area of the region satisfying the inequalities mod x minus y less than or equal to 1, y greater than or equal to 0, y less than or equal to 1 is beautiful. Let's draw this one. Y greater than or equal to 0. This is this. Y less than or equal to 1. Y equal to 1 is this region. We're talking about this band. Mod x minus y less than or equal to 1. Okay, mod x minus y equal to 1. Or y equals mod x minus 1. Now, y equal to mod x is a curve like this. Mod x minus 1 will be a curve like this. Shift it down by 1. So this is 0, 0. This is x-axis. This is a line y equal to 0. This is a line y equal to 1. We're talking about this band here. On top of, inside that band sits this y equal to mod x minus 1 line. So this point will be minus 1, 0, minus 1. Put x equal to 0, y will be minus 1. This point, when will y be 0? When x is 1, 1, 0, or x is minus 1, minus 1, 0. When will y be 1? So 1 equals mod x minus 1. Mod x should be 2, 2, 0. Or minus 2, 0. Or this distance is 4. This distance is 2. We're talking about a trapezium of height 1 and sides, parallel sides 4 and 2. Half into 4 plus 2 into 1. Half of 6, 3 square units. Okay. Let's look at this one. If y is a negative number such that 2 power y square log 5 to the base 3 equal to 5 power log 3 to the base 2. And so, very often in these kind of log questions where an exponent is there and log is there, a simple trick in the book is take log on both sides. That might simplify something. And so I'm going to try to do that. Take log on both sides and we'll try to do this. So this becomes y square log 5 to the base 3 times log 2 is equal to log 3 to the base 2 times log 5. This is 5 power log 3 to the base 2. So this will be log 3 to the base 2 times log 5. Log 5 to the base 3 here
and a log 5 here. So we can choose the base to be 3. It's in our hands, we can choose any base. If we do that, then this log 5 to the base 3, this log 5 to the base 3, these two get cancelled. So we have y square here equal to log 3 to the base 2 by log 2 to the base 3. Log 2 to the base 3 is 1 by log 3 to the base 2. So this is nothing but y square equals log 3 to the base 2 whole square, or y should be log 3 to the base 2. But the problem here is we know y is negative. It's been given very clearly that y is negative. So y is not log 3 to the base 2. It is log 3 to the base 2 times minus 1. Minus of log 3 to the base 2. Log 3 to the base 2 and minus of log 3 to the base 2 is nothing but log 1 by 3 to the base 2. 2 power something is 3. 2 power minus of something, minus of the same thing will be 1 by 3. So minus log 3 to the base 2 is nothing but log 1 by 3 to the base 2. We're looking for a choice that says that. It's just this. Beautiful question. Nice, wonderful, challenging question. What you're looking for here when you're combining exponents and log, that first step of unlocking, that is take log on both sides. That's a beautiful trick. So keep that in mind. The moment you take log on both sides and you're plugging that in, now the second trick is there is a log 5 to the base 3 here. We can choose any base. Choose the base to be 3. That means you put a base 3 here and a base 3 here. These two get cancelled, knocked off. After this, log 3 to the base 2 and log 2 to the base 3 are just reciprocals of each other. Final thing, when you come here, we have to keep in mind that the question clearly states that y is a negative number. That's something to keep in mind. So the answer is log 1 by 3 to the base 2. The number of pairs of integers x comma y satisfying x greater than or equal to y greater than or equal to minus 20 and 2x plus 5y is 99 is. These kind of questions, find one solution and then build from there. Find one solution and then build from there. Fine. 2x plus 5y is 99. It's going to be an even number. So from 99 subtract an even number and then find a multiple of 5. So if you from 99 you subtract an even number, you'll get an odd number. Find an odd multiple of 5. The best case I can think of is when y is 19, 95 comes about. So the one solution that I can think of is x equal to 2, y equal to 19. This works. Fine. X greater than or equal to y greater than or equal to minus 20. We can't count this. Fine. This is not a right solution. X is 2, y is 19, does not work for us. Fine. But this is one solution. We've got one solution. After this, what we do? You keep increasing x, y should decrease. Or if you keep decreasing x, y should increase. That much we know. X is multiplied by 2, y is multiplied by 5. Think about this. You have to find something to go up in x that should be offset by a fall in y. And so any increase in x will increase this by multiples of 2. Any change in y will change this in multiples of 5. Or if you change x by 5, you'll change y by 2. What does that mean? If you put x equal to 7, y will be 14. You increase this by 5, sorry, y will be 17. Decrease this by 2. The total goes up by 10, the total falls by 10, it gets cancelled out. So x equal to 7 gives us 2 into 7, 14, plus 85 is 99. That works. Next one, x will be 12, y will be 15. X will be 17, y will be 13, and so on. And so we've now got a pattern for all the values. Now let's put that condition. X greater than or equal to y greater than or equal to minus 20. Here x is not greater than or equal to y. Here x is not greater than or equal to y. Here no. This one works. You keep decreasing x and increasing y. Y is 21 and x is minus 3. None of those will work. So we're looking for solutions below this. 17, 13 is the first starting point. After that, this becomes 22, y becomes 11. This becomes 27, y becomes 9. 27 into 2 is 54, 9 into 5 is 45, they add up to 99. Right? So the first condition, x greater than or equal to y, works. Right? Now we have to think about y greater than or equal to minus 20. This keeps on going down. You go 9, 7, 5, 3, 1, minus 1, etc., 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 etc. But then till what point? It starts at 13, 11, 9, 7, 1, minus 1, minus 3, minus 19, it can't go any further. It can't go below minus 19. It becomes minus 21. That condition won't get satisfied. All we need to do is figure out how many are there in this count. We're good to go. And so minus 1 to minus 19 is 10 sets. 1, 3, 5, 1, 2, 3, 4, 5, 6, 7. 7 plus 10, 17 values are there. And very interesting set. These kind of questions, find one solution and then think about how x and y will move such that one offsets the other. So you have a pattern. After we find the pattern, look at the other conditions that are sitting there. So x greater than or equal to y greater than or equal to minus 20. In some cases, it could be mod x greater than y. It could be x and y both positive. Some x and y are natural numbers, something else. Find one solution and then you find the pattern. And then you think about how many numbers, how many pairs will satisfy the other condition. The value of log of a by b to the base a plus log of b by a to the base b for 1 less than a less than or equal to b cannot be equal to. Let's look at this. Let's first, we know log of a by b is log a minus log b. So this one will simplify it as log a to the base a minus log b to the base a. This one we can split as log b to the base b minus log a to the base b. This is 1, this is 1. So this 2 sitting here, 2 minus of log b to the base a plus log a to the base b. I'm going to call it as x plus 1 by x. Why am I writing like this? If log b to the base a were x, then log a to the base b would be 1 by x. Log a to the base b is just a reciprocal of log b to the base a. Right? So it cannot be equal to, is what we are saying. It cannot be equal to. First of all, this is a beautiful function, x plus 1 by x. Simple idea is either always greater than or equal to 2, it's greater than or equal to 2, or it is less than or equal to minus 2. This cannot lie between minus 2 and plus 2. Right? So if it were 2, this will be 0, so 0 is possible. If it were 3, it can be minus 1, so this is possible, this is possible. If it were minus 2.5, it could be minus 1.5, that's possible. For this expression to be 1, x plus 1 by x should be 1, that's not possible, that's what we are looking at. One aspect here we are looking at is logarithm property being manipulated a little bit. The second idea here is very powerful. X plus 1 by x is either greater than or equal to 2 or less than or equal to minus 2. It cannot sit between minus 2 and plus 2. That's the one idea we're plugging in here. So if it were 2, the expression will be 0. If it were 3, expression will be minus 1. If it were 2.5, expression will be minus 0.5. Expression can never be equal to 1 because then it will mean x plus 1 by x has to be 1. That's not possible. Let's do this one. Let the mth and nth terms of a geometric progression be 3 by 4 and 12 respectively, where m is less than n. If the common ratio of the progression is an integer r, then the smallest possible value of r plus n minus m is. Right? So we are having 3 by 4 here. Then we go to 12. And so m is less than n. So this is the mth term. This is the nth term. Straight away we know that n minus m is positive. Right? We may take a certain number of steps to go here. Put 4, it could be 5. We don't know that. Right? So we know that r is an integer. Right? So if r were an integer, r power some k will take us from 3 by 4 to 12. Right? So or r power k is 12 by 3 by 4. 12 by 3 by 4 is 12 into 4 by 3, which is 16. R is an integer. 16 can be written as 2 power 4 or 4 square. When we are looking for r to be an integer and k to be an integer, 2 power 4 or 4 square, one of these two. So r is 2 or r could be 4. K is nothing but the difference between n and m. We figure out, substitute, simplify, find this. There's one catch here, keep this in mind. R can be negative. So r can be minus 2, whole power 4 is also 16. R can be minus 4. We want r plus n minus m to be minimum. So definitely choose r to be negative. That doesn't change life. So we're looking at either minus 2 whole power 4 or minus 4 whole power 2. This number is k which is effectively n minus m. From m, how many terms do we have to jump to the nth term? So either r is minus 2 and n minus m is plus 4, or r is minus 4 and n minus m is plus 2. We want the smallest possible value of this. So we'll have to choose r is minus 4, n minus m is plus 2, minus 4 plus 2 is minus 2. When the common ratio is minus 4, you're looking for the second term from 3 by 4 to go to 12. Right? Let's solve this one. Wonderful question, really tough, but there's a very simple, juicy way of doing this. I'm going to do it with the juiciest method possible. I'll give you the starting step for doing the more rigorous method, but not going to get into that. Right? X and y are positive real numbers satisfying x plus y is 102. Then the minimum possible value of 2601 into 1 plus 1 by x into 1 plus 1 by y. Talk about positive real numbers. And the best way to go about it is pick two extremes. Put x is 0.1, y is 101.9, or x is 1, y is 101. The other extreme, put x is 51, y is 51. You're through. Let's do that. Let's put x is 1, y is 101. We worry only about this. 1 plus 1 by 1 into 1 plus 1 by 101. This is one possibility. Or we're talking about 1 plus 1 by 51 into 1 plus 1 by 51. This is barely more than 1, but this is 2. It's 2 into 1 point something. Both of these are barely more than 1. And so this is going to be way greater than this. Or we want to find the minimum possible value. The way to go about it, plonk x as 51, y as 51, both equal, we are good to go. How do we do that? Let's look at that. Put x as 51. So looking at 2601 into 1 plus 1 by 51, or 52 by 51 into 52 by 51. 1 plus 1 by 51 is 52 by 51. 51 into 51, funnily enough, is 2601. 52 into 52, you should find that, but I happen to know that it is 2704. So the textbook way of doing this, trying to find the maximum way of this, maximum range for this, all of that is tricky. But the quick and dirty way, we're told that both are positive real numbers. Stick both of them as equal, stick both of them far apart, and then see where you land up. Both of them far apart takes us to a larger number. Equal takes us to a very small number. Go for the small number, you're good to go. The other way of doing this, x plus y is 102. I'm going to anchor around the midpoint. So I'm going to say x is 51 plus k, y is 51 minus k. So we've incorporated that constraint with a single variable. So you can say 2601 into 1 plus 1 by 51 plus k into 1 plus 1 by 51 minus k, and simplify. You'll get an expression in terms of k. You have a look at it, you'll be able to find where it goes to maximum, where it goes to minimum, and then you're good to go. The textbook method works like this. You won't have to differentiate or anything, you can still find the answer. It's not rocket science. That method also takes you to the answer reasonably quickly, but this is far better. Plonk in one extreme, plonk in the other extreme, you're good to go. If x and y are non-negative integers such that x plus 9 is equal to z, y plus 1 is equal to z, and x plus y less than z plus 5, then the maximum possible value of 2x plus y equals. So to start with, I like the idea of drawing a number line, which you can plot everything there. There is x plus 9 is z, this is plus 9, y plus 1 is z, so y is here. All three are linked. When I started doing this, then I realized I don't even need to draw the number line because all three can be captured with the same variable. Right? So here we have x plus y, which is x plus 8 less than x plus 9 plus 5, or 2x plus 8 is less than x plus 14, or x is less than 6. Lovely. The maximum possible value of 2x plus y, higher x is, higher y will be. We know that they are non-negative integers. X is less than 6. the x can be 5. If x were 5, then y would be x plus 8, 13. 2x plus y, 2 into 5 plus 13, 10 plus 13, 23. That's the maximum. I started off doing this, but I realized that all three are part of the same variable. Becomes a very simple question. Let's try this one question on functions. Let's look at this. X square plus ax plus b. F of x is x square plus ax plus b. G of x is f of x plus 1 minus f of x minus 1. F of x is greater than or equal to 0 for all real x, and g of 20 is 72, the smallest possible value of b. This is a brilliant starting point. So let's define g of x first. F of x plus 1 minus f of x minus 1. So this is x plus 1 whole square plus a times x plus 1 plus b minus of x minus 1 whole square plus a times x minus 1 plus b. We subtract one from the other. There will be a plus ax that will get cancelled, plus a minus a, subtract that, you will get 2a, plus b minus b, this will go off. X square plus 2x plus 1, x square minus 2x plus 1, this will be 4x. We know g of 20 equals 72. Let's plug that in. G of 20 is 4 into 20 plus 2a. This is 72. 4 into 20 is 80. 80 plus 2a is 72. So 2a is minus 8, or a is minus 4. Lovely. Now let's come back to the remaining part of the question. A is minus 4. We want to find the smallest possible value of b. So x square minus 4x plus b. This is f of x. We know f of x is greater than or equal to 0. What does this mean? This means that this number can be expressed as a square plus something, which is when it will be greater than or equal to 0. X square minus 4x plus 4. This can be written as x minus 2 the whole square. X square minus 4x plus 4 is x minus 2 whole square. So this will be plus b minus 4 greater than or equal to 0. Or b should be at least 4. Fine, wonderful question. First we find the expression for g of x, then we plug in g of 20 is 72 and find a, then come back to this expression. When we go to that expression, we say it's x square minus 4x plus b. We know that's always greater than or equal to 0. That means it can be reduced as a perfect square, square of a quadratic, x minus a whole square, something of that form, plus a positive number or a non-negative number. So we can deduce what b will be by completing the square of that expression. So the smallest value b can take is 4. This is a lovely question, wonderfully challenging question. Let's look at this one. In how many ways can a pair of integers x comma a be chosen such that x square minus 2 mod x plus modulus of a minus 2 is equal to 0? Lovely question, because this can be framed as an equation in mod x. And so the wonderful idea. And so now think about this. So we have mod x square minus 2 mod x plus a positive number is equal to 0. The beauty here is x square mod x square minus 2 mod x plus 1 equal to 0 is a nice square of a quadratic expression. How do I say that? So mod x minus 1 whole square is x square minus 2 mod x plus 1. This can be equal to 0 when mod x is equal to 1, but this number cannot be more than 1. So straight away we know that this constant term, if it were more than 1, we have no solution. It is positive. If they are more than 1, we have no solution. We know we are talking about integers, or modulus of a minus 2. Modulus of a minus 2 can be 0 or it can be 1. Nothing else is possible. Fine. So I'm going to look at both possibilities. Let's say that's equal to 0. So now we have mod x the whole square minus 2 mod x is equal to 0. Mod x into mod x minus 2 equal to 0, or x could be 0, x could be 2, x could be minus 2. For all of these possibilities, a equal to 2 works. So there are 3 possible solutions here. x and a 0, 2, 2, 2, minus 2, 2. 3 possibilities work. Now let's go to the other scenario where we say mod x minus 1 whole square is equal to 0. And so mod x minus 1 whole square is 0. This means mod x is 1. X could be 1 or minus 1. This is the scenario when modulus of a minus 2 is 1 or a is 3 or a is 1. A minus 2 is 1 or a minus 2 is minus 1. Both are possible. Now, it could be x is 1, a is 3, x is 1, a is 1, or x is minus 1, a is 3, x is minus 1, a is 1. 4 possibilities exist. All 4 are possible. Here we have 3 possibilities, here we have 4, totally 7. Wonderful question, delightful question from the idea of completion of squares. We start off with that and then isolate that the constant term can only be 0 or 1. Plug in the constant term to be 0, find all possible solutions. Put the constant term to be 1 and find all possible solutions. Be rigorous. Remember, you're dealing with modulus of x. Remember, you're dealing with modulus of a minus 2. Find wonderful questions with the delightful 7 answers. For real x, the maximum possible value of x by square root of 1 plus x power 4. These kind of questions, trick 1 in the book. Whenever there's a square root sitting here, see if you can simplify this expression to have some kind of symmetry. What do I mean by that? There's an x on top and then the square root and 1 plus x power 4. 1 and x power 4 are far away and x is in the middle. This is x power 1, x power 0, x power 4. We're all over the place. But if you simplify this, make one very simple change. Divide by x in the numerator and denominator. So numerator is x by x. Denominator is 1 plus x power 4 by x square, because inside the square root. Okay. X by x is 1. Is 1 by square root of 1 by x square plus x square. Lovely. Once you do this, you're through. We've already seen this in a couple of questions. X plus 1 by x is either greater than or equal to 2 or less than or equal to 1 minus 2. 1 by x square plus x square is always greater than or equal to 2. Fine. So I'm going to start with this. X square plus 1 by x square is greater than or equal to 2. Or square root of x square plus 1 by x square is greater than or equal to root 2. 1 by square root of x square plus 1 by x square is less than or equal to 1 by root 2, or the maximum possible value 1 by root 2. The first thing, divide numerator and denominator by x. Numerator gets divided by x, denominator gets divided by x square inside the root. Then modify this. You need to be able to see this expression as this expression. We know how x square plus 1 by x square behaves. Therefore, we know how square root of x square plus 1 by x square behaves. Therefore, we know how 1 by square root of x square plus 1 by x square behaves. So, this is greater than or equal to 2. This is greater than or equal to root 2. 1 by this is less than or equal to 1 by root. The number of integers that satisfy the inequality x square minus 5x plus 7 whole power x plus 1 equal to 1. And so, x square minus 5x plus 7 whole power x plus 1 equal to 1. When can this happen? When can an exponent be equal to 1? Very simple idea. First up, 5 power 0 is 1. Anything power 0 is 1. So this goes to 0, we strike jackpot. And so that's one approach, one starting point. Another thing, 1 power anything is 1. 1 power 3, 1 power 5, 1 power 100, all of those are 1. So that's useful. These two, everyone will find. There's one other possibility. You could have minus 1 whole power 4 equal to 1. Minus 1 raised to the power an even number is 1. Minus 1 power 3 is minus 1. But minus 1 square, minus 1 power 6, minus 1 power 8, all of those are 1. So the three possibilities we need to account for. One, we've got to say the power goes to 0 and then simplify and see if it works. Then say the expression is plus 1, worry about the power. Then expression is minus 1, worry about the power being an even number. And let's do all three. First of all, power going to 0, so x is minus 1. That is a possibility. We substitute minus 1 here. Minus 1 whole square is 1. Minus 5 plus, so that works. 1 plus 5 plus 7 whole power 0. That will work. So x equal to minus 1 is one obvious possibility. We have it in the bag. Let's go to the next. X square minus 5x plus 7 is equal to 1, or x square minus 5x plus 6 equal to 0, x minus 2 into x minus 3 is equal to 0, or x could be 2 or 3. If you put x as 2 or 3, this will become cube or power 4, 1 cube, 1 power 4, both of them work. So x equal to 2 works, x equal to 3 works, x equal to minus 1 works. Now let's go to the final set of possibilities. X square minus 5x plus 7 is equal to minus 1, or x square minus 5x plus 8 is equal to 0. So number of integers that satisfy the equality, x square minus 5x plus 8 equal to 0, you have to split minus 5 in order to get a product of 8. X square minus 5x plus 8 equal to 0. I don't think there are integer values that satisfy this, because it's not something that splits easy. It's 2 into 4 or 1 into 8. Minus 2 into minus 4, minus 1 into 8, minus 8 don't work here. So there's no integer solution possible here. So 2 and 3 work, minus 1 works. There are 3 solutions possible. Generally, as a rule of thumb, you'll have to worry about this possibility also. In this case, it doesn't matter.
F of x plus y is f of x into f of y, and f of 5 is 4. What is f of 10 minus f of minus 10 equal to? All these questions, f of x plus y is f of x into f of y. If you add a number, the number does not change. Think about a number like that. There's x plus y here, put y equal to 0. F of x plus 0 is f of x into f of 0. F of x is f of x into f of 0. Wonderful. Or f of 0 is 1. Assuming f of x is not 0. F of x is not 0, that much we know. F of 0 is 1. So f of 5 is 4. F of 5 plus 5 is f of 5 into f of 5. Or f of 10 is 4 into 4, which is 16. F of 10 plus minus 10 is f of 10 into f of minus 10. F of 0 is 16 into f of minus 10, or f of minus 10 is 1 by 16. If you're looking for 16 minus 1 by 16, it should be this. 1 by 16 is 0.0625. Even if you didn't know that, from the choices you can get there. Let m be positive integers if x square plus mx plus 2n and x square plus 2nx plus m equal to 0 have real roots in the smallest possible value of m plus n. Have real roots. So b square minus 4ac should be greater than or equal to 0. So m square minus 8n is greater than or equal to 0. 2n the whole square minus 4m should be greater than or equal to 0. Or 4n square minus 4m is greater than or equal to 0. N square minus m greater than or equal to 0. M square minus 8n greater than or equal to 0. Lovely. We have this. After this, does not do this algebraically. It's a pain. Find m square is greater than or equal to 8n. N square minus m greater than or equal to 0. From now on, we want m plus n to be as small as possible. You put in our positive integers, you put n equal to 1. Right? Then m square should be greater than or equal to 8. It should be 3 or more. If you put m as 3, then n should be 2 or more. So n equal to 1 does not work. Wonderful. So if you put n equal to 1, it doesn't work, because then both conditions cannot be satisfied. Put n equal to 2. N square is 4. 4 minus m greater than or equal to 0, or m is 4 or lesser. M square minus 8 into 2 greater than or equal to 0. M square minus 16 is greater than or equal to 0. M is 4 or more, or m could be 4. N equal to 2, m equal to 4 works. It just works. This side becomes 0, that side becomes 0. Both times the real roots are equal, but it works. 2 plus 4 is 6. Nothing else will work. That much we know. If we put n equal to 1, it doesn't work. N equal to 2, m is 4, the best case scenario, and it just works. We can confidently mark this. Do not go about this algebraically. Plug in a few values, see where it takes us. It's a beautiful question, nice and tough. Fine, so let's write this down. We have log 30 to the base a is capital A. Log 5 by 3 to the base a is minus b. Log a to the base 2 is 1 by 3. This means log 2 to the base a is 3. And a cube is 2. And so there's something that gives us links 30 to a, 5 by 3 to a, and 2 to a. Right? We want to find log a to the base 3. If we find log 3 to the base a, we are through. If we know this, we know this. But this fine. So we know the link between a and 2. We need to find the link between a and 3. And if we can find the link between kind of 2 and 3, we may be through. One look at the choices tells us that a plus b is involved everywhere. So there's something to go from there as well. So how do we get a plus b? If we subtract this from this, I'll get a plus b. Why am I doing that? We know that log m minus log n is log of m by n. So log of 30 by 5 by 3 we can get, which is log of 30 into 3 by 5, which is log 18 to the base a. 18 is a combination of 2's and 3's, so I like that. So let's get that. So log 18 to the base a, this minus this is a plus b. How do we simplify this? Log 18 to the base a. Log 18 to the base a is log 9 to the base a plus log 2 to the base a, or 2 times log 3 to the base a plus log 2 to the base a. Lovely. Log 18 to the base a is a plus b. Log 2 to the base a is 3. So a plus b is 2 times log 3 to the base a plus 3, or log 3 to the base a is a plus b minus 3 by 2. We are looking for log a to the base 3 is 2 by a plus b minus 3. 2 into 4 into 8 into 16 divided by log 4 to the base 2 whole square. Log 4 to the base 2 is 2. Log 8 to the base 4. This is log 8 by log 4. Both to the base 2 is 3 by 2. Log 16 to the base 8 is log 16 by log 8. I can select the base to be 2. This is 4 by 3. So this won't calculate only the denominator. We'll come to the numerator. 2 square into 3 by 2 cube into 4 by 3 power 4. 2 into 2 into 3 by 2 into 3 by 2 into 3 by 2 into 4 by 3 into 4 by 3 into 4 by 3 into 4 by 3. The 3 3's get cancelled. 2 2's get cancelled. This is 2. So now let's plug in the numerator. 2 into 4 into 8 into 16 divided by 2 into 4 into 4 into 4 by 3. The 3 goes here. 2 into 4 is 8. 4 into 4 is 16. So it is 2 into 4 into 3. 8 into 3, 24. Very routine question. You should be knocking it off the park. Let k be a constant. The equations kx plus y equal to 3 and 4x plus ky equal to 4 have a unique solution. For unique solution, system a1 by a2 should be not equal to b1 by b2. That's all we need to do. K by 4 is not equal to 1 by k. K square is not equal to 4. K should not be equal to plus or minus 2, or modulus of k not equal to 2. It's a 45-second question. You need to know this property. If you're preparing for the exam and you don't know this property, then that is the issue. Beautiful question. I really like this question. The area and square units enclosed by the lines x equal to 2, y equal to modulus of x minus 2 plus 4, and the x-axis and y-axis are equal to. Wonderful. X-axis is this, y-axis is this. X equal to 2 is a line parallel to the y-axis. So we've got this. These three we have in the back. 0, 0, x-axis, y-axis. We can somehow get this. We are through. I'm going to get this slowly, methodically. We get this diagram shape, we are through. Fine. So for that, I'm going to go step by step. I'm going to draw y equal to mod x because I know that y equal to x is a line like this. Y equal to mod x is a line like this. It will be 0 at x equal to 0. And this is y equal to mod x. Now I want to say I want to y equal to modulus of x minus 2. Think about it. This will go to 0 when x is 2. Or this is nothing. Shifting it to the right. Y equal to mod x is like this. Y equal to modulus of x minus 2 will be like this. How will y equal to modulus of x minus 2 plus 4 be? Add 4. 1, 2, 3, 4. It will be a line like this. Now take that to our original diagram. So this is 2, 0 and then 2, 4. You are looking at a line like this. This point is 2, 4. You put x is 2, y will be 4. That's a bottom for this. You're looking at a curve like this. This distance is 2 units. This distance is 4 units. There's a straight line. The angle is 45 degrees. The modulus of x line. This is 2. This is 2. This area is half into 2 into 2, 2 square units. This area is 2 into 4, 8. 8 plus 2, 10. If you know y equal to mod x, you should have a sense of y equal to modulus of x minus 2. If you know y equal to f of x, you know y equal to f of x plus 4. Just take it higher. Then you visualize the shape. Think of the trapezium. Think of a right angle triangle and a rectangle. Then you're through. x1 is minus m minus 1. xm is xm plus 1 plus m plus 1. For every positive integer m. Let's do this. All of these questions, a simple pattern should emerge. x1 is minus 1. x1 is x2 plus 2. Minus 1 is x2 plus 2. x2 is minus 3. x2 is x3 plus 3. Minus 3 is x3 plus 3. x3 is minus 6. x1 is minus 1. x2 is minus 3. x3 is minus 6. x4 is x3 plus 4. Sorry, x3 is x4 plus 4. Minus 6 equals x4 plus 4. x4 is minus 10. Beautiful pattern emerges. You take the minus out. This is 1, 3, 6, 10. 1, 1 plus 2, 1 plus 2 plus 3, 1 plus 2 plus 3 plus 4. And then stick a minus in between. x100 is sum of all numbers till 100 with a minus 1 before that. Minus into 100 into 101 by 2 minus 5050. Lovely. Slot 3 quant. Beautiful question. Nice challenging question. Took me a long time to solve this. I did not go for it in the exam, but it's a beautiful question nevertheless. Let's look at this. 14 par A is 36 par B equals 84 par C. What is 6B times 1 by C minus 1 by A equal to? And so there's some 1 by C, there's some 1 by A. A lot of these questions kind of get simplified if you take log on both sides. Right? So, but there's links A, B and C. I'm going to say, let's call this as K. Right? Beautiful. So 14 power A is equal to K. What does it mean? 14 raised to the power something is K. So what does it mean? This means log K to the base 14 is A. Log K to the base 36 is B. The very definition, log K to the 36 is B, that means 36 par B is K. Log K to the base 84 is C. But we're not dealing with A, B and C, we're dealing with a 1 by C, 1 by A and all that. So let's see, can we flip this? Log
14 to the base k. Log k to the base 14 is a. Log 14 to the base k is 1 by a. Log 36 to the base k is 1 by b. Log 84 to the base k is 1 by c. Lovely. Multiple advantages here. We're dealing with base k. So therefore that is very useful. And we want to find 1 by c minus 1 by a. So let's forget this for the time being. So 1 by c minus 1 by a. This is equal to log 84 to the base k minus log 14 to the base k. 84 by 14 is 6. This is log 6 to the base k. Log a minus log b is log of a by b. Brilliant. So log 6 to the base k is 1 by c minus 1 by a. Log 36 to the base k is 1 by b. Log 36 to the base k is nothing but 2 times log 6 to the base k. Now we are practically 2. Log 36 to the base k is 2 times log 6 to the base k. 6 square is 36. And so 36 to the base k is 1 by b, or we know, we're going to go to the next slide, 1 by b equals is 2 times 1 by c minus 1 by a, or 1 equals 2b times 1 by c minus 1 by a. What is 6b? 3 equals 6b times 1 by c minus 1 by a. Wonderful, beautiful. The key thing here, we plonk all 3 to be equal to k. And then you realize that if 14 power a is equal to k, that means log k to the base 14 is a. Or log 14 to the base k is 1 by a. Why are we chasing 1 by a? Because this 1 by a is sitting here. We get 1 by a and 1 by c in terms of log expressions, and then do one minus the other. Therefore, we get a sense of 1 by c minus a, 1 by a. We go that far, we straight away get that this is linked to 1 by b. And we get through. Beautiful question, nice tough question, classic question where the expression you're looking for, if you go looking to find it, then the question becomes simpler. You want to find 1 by c, you want to find 1 by a, you want to do 1 by c minus 1 by a, so go chasing that, it should fall in place. X square plus 2x minus 15 by x square minus 7x minus 18 is negative if and only if, effectively solve for this inequality, this is less than 0. X square plus 2x minus 15 is, it is x plus 5 into x minus 3 divided by x square minus 7x minus 18 minus 9 plus 2 x minus 9 into x plus 2. It should be less than 0. And we're going to think about this as roots on a number line. So draw the number line. This minus 5 works. Let's put 0 here. Minus 5, minus 2, 3 and 9. These are the turning points for this. So if x were greater than 9, then this all would be positive, the expression would be positive. X were less than 9 but greater than 3, then x minus 9 would be negative. These 3 are positive. So here the expression would be positive, here the expression would be negative. The moment I hang on to this, everything else also falls in place. In this range it will be positive, this range it will be negative, this range it will be positive. Imagine this, below minus 5, each of these terms is negative. Negative and negative, positive, negative, negative, positive, positive by positive, positive. So here it won't work. Here the inequality does not hold good. The inequality we are solving for is this expression less than 0. Right? So where does it work? It works from minus 5 to minus 2 and 3 to 9. Minus 5 to minus 2, 3 to 9. Perfect. All less than, no less than or equal to business. It's clearly negative. So life is easy. Minus 5 to minus 2, 3 to 9. Find all the roots. Roots are turning points, and then we are done after that. The number of integers n that satisfy the inequalities, modulus of n minus 60 less than modulus of n minus 100 less than modulus of n minus 20 is very interesting. First thing we need to know is if you have 2 points on the number line, x and y, then the distance between these 2 points is modulus of x minus y or modulus of y minus x, one of the two, doesn't matter. Right? So now we're going to treat this as this inequality and then this inequality. Then so let's say modulus of n minus 60 less than modulus of n minus 100. So let's put 60 here and 100 here. So distance modulus of n minus 60 less than modulus of n minus 100. That is, if I have n, distance from 60 is less than distance from 100. Right? Or think about this, n were here, distance from 60 would be less than distance from 100. If n were here, here, throughout it will work. There will be the turning point will be at 80. Modulus of 80 minus 60 is equal to modulus of 80 minus 100. So where will it work? Where will it hold good? It will hold good when n is less than 80. N can be anywhere here. Modulus of n minus 60 be less than modulus of n minus 100. Because 40 minus 60 modulus is 20, 40 minus 100 modulus is 60. So this tells us n is less than 80. Let's attack this one. So for this, we're thinking about 100 and 20. We know straight away that the turning point is 60. Distance from 100 is less than distance from 20. Or this number is closer to 100. Or n should be greater than 60. This one works when n is less than 80. That one works when n is greater than 60. We're looking for numbers greater than 60. Less than 80, 61 to 79, 19 different numbers. That's an answer. 61, 62, 63, 64 till 69. Clearly, we are looking at integers, not a range. So 19 different integers work, 61 through to 79. Right? The key point here is if you have 2 points x and y on the number line, the distance between the 2 points is modulus of x minus y, which is nothing but modulus of y minus x. Both are same. 5 minus log square root of 1 plus x to the base 10 plus 4 log 1 minus x to the base 10 equals that. So 5 minus log to the base 10 of square root of 1 plus x plus 4 log to the base 10 of square root of 1 minus x equals, this can be broken as log of 1 by square root of 1 plus x into 1 by square root of 1 minus x. Or this side is minus log of square root of 1 plus x minus log of square root of 1 minus x. Log AB is log A plus log B. Log of 1 by A is minus log A. Log of 1 by B is minus log B. 1 by B is B power minus 1. The idea we're using here. So I can move some logs this side or everything that side. I can shift something around. Minus log of 1 plus x minus log of 1 plus x. These two will get cancelled. Or 5 equals minus log square root of 1 minus x minus 4 log square root of 1 minus x. 5 equals minus 5 log of square root of 1 minus x, or log of square root of 1 minus x to the base 10 is minus 1. Or square root of 1 minus x is 10 power minus 1, which is 1 by 10. 1 minus x is 1 by 100. X is 99 by 100. We want to find 100x. 100x equals 99. Methodically solve this. We're using two ideas. Log AB is log A plus log B. Next idea, log of 1 by A is minus log A. Right, so log 1 by A is minus of log A. Log AB is log A plus log B. A basket of 2 apples, 4 oranges and 6 mangoes costs the same as a basket of 1 apple, 4 oranges and 8 mangoes. 2A plus 4O plus 6M equals 1A plus 4O plus 4M. Or a basket of 8 oranges and 7 mangoes equal to 8 oranges plus 7 mangoes. Then the number of mangoes in a basket of mangoes that are the same cost as the other. We have to get each in terms of the other. Let me see which equation works best. There's no apples at all in this. That should be a help. 8 oranges plus 7 mangoes. I'm going to double this. I want to have 8 oranges and 7 mangoes. 6 plus 4, 10. 4 plus 4, 8. Let me see. Both have 4 oranges, so I'm going to use these two. Cancel the 4 oranges part and then say 2 apples plus 6 mangoes equals 1 apple plus 4 mangoes, or an apple equals, let me just do 2 apples plus 4 oranges plus 6 mangoes, 1 apple plus 4 oranges plus 8 mangoes. Luckily now this is 8, I made that mistake, it should be 8. An apple equals 2 mangoes. Lovely, that is helpful. An apple is 2 mangoes, we can plug that here. So 1 apple, 2 mangoes plus 4 oranges plus 8 mangoes is 8 oranges plus 7 mangoes. This 4 oranges plus 10 mangoes is 8 oranges plus 7 mangoes. 3 mangoes equals 4 oranges. An apple is 2 mangoes. We can get everything in terms of mangoes. Let's do this. Apple is 2 mangoes. Orange is 3 mangoes is 4 oranges, or 1 orange is 3/4 of a mango. Then the number of mangoes in a basket of mangoes that has the same cost as the other basket. Essentially represent everything in terms of mangoes. 2 apples, 2 into 2 mangoes, plus 4 oranges, 4 into 3/4 mangoes, plus 6 mangoes. That is the cost of the first basket. So it's 4 mangoes plus 3 mangoes plus 6 mangoes. 7 plus 6, 13 should be the answer. Simple dealing with linear equation. There's 4 oranges in 2 of these. Knock that off. Oranges go off. We have an equation in apples and mangoes. Get apples in terms of mangoes. Plug that in the next one. Get everything in terms of mangoes. We are through. R is a constant such that x modulus of x square minus 4x minus 13 equals R has exactly 3 distinct roots. There's the value of R is. I made a mess of this question, so I'm going to take revenge on this. Not that it's worth something. So x square minus 4x minus 13. It looks like it cannot be factorized. It cannot be. It is not required that we factorize this. Fine. So the idea is it has exactly 3 roots. One is, suppose this were equal to say 10. What am I doing? I'm saying this is equal to plus 10 gives us a solution. This equal to minus 10 gives us a solution. That means plus 10 will give us 2 roots, minus 10 will give us 2 roots. What's happening here? We have only 3 roots. It is telling us that put as plus 10, you'll get 2. Put as minus 10, you'll get only 1 root. Or the discriminant goes to 0. Or the other way around. That's what this question is saying. Right, so let's simplify this then. So let's complete this square. X square minus 4x plus 4 is x minus 2 whole square. Minus 17 equals R. Or modulus of x minus 2 whole square minus 17. Oops. Equals R. Or x minus 2 whole square minus 17 equal to R. X minus 2 whole square minus 17 equals minus R. This is what you're solving for effectively. Or x minus 2 whole square equals R minus 17. Or x minus 2 whole square equals minus R minus 17. This will give us 2 roots. This could give us 2 roots. One of these two gives us only 1 root. X is only 2. That's effectively what we're trying to solve for. When will that work? One of these has to go to 0. If x were 17, this will go to 0. X were minus 17 will go to 0. So the value of R 17 works. Done. This goes to 0. X minus 2 whole square is 0, has only 1 root, x equal to 2. There, if x is 17 with some other value, I don't know whether that works. Let me just check that out. X is 17 takes us to 0, or x minus 2 whole square minus 17 equals minus 17. Minus R minus 17, minus 17, minus 17. Let me just check this. If you put a 17, very interesting. It should go to 0. This goes to 0. X equal to 2 works. X equal to 2 will work. Is there a scenario where this goes to minus 17 at all? X minus 2 whole square minus 17 equals minus 17. Sorry, it should be minus R plus 17 minus R plus 17. R equal to 17 works. R equal to minus 17 also works. One of those will give 2 roots. The other will take care of itself. So there are 3 roots possible. only when x is 17. This works. This is r plus 17 minus r plus 17. So 3 roots are possible when r is 17. x0 is 1, x1 is 2, xn plus 2 is 1 plus xn plus 1 by xn. So x2 is 1 plus x1 by x0. 1 plus 2 by 1, which is 3. x2 is 3. x3, 1 plus previous term divided by this. 1 plus 3, 4 by 2, 2. x4, 1 plus 2 divided by this. 1 plus 2 by 3. This is 1 plus 3 by 2. x5, 1 plus 1 by 2, 2 by 2, 1. x6, 1 plus 1 by 1, 2 by 1, 2, and so on. And there's some pattern here. The next 2, 0, 2, 1 is equal to. Very interesting. Each term is generated by the previous two terms. That much I know. This is generated by plugging in something here. This is generated by plugging in something here. This is generated by plugging in a rule here. The moment a pattern recurs, after that it will become a cycle. So if I see a 2, 3 somewhere, this 2, 3 generates a 2, that 2, 3 will generate a 2. And so x7, 1 plus 2, 3 by 1, 3. x8, 1 plus 3, 4 by 2, 2. 1, 2, 3, 2, 1, 1, 2, 3, 2. 2, 3, 2 or 1, 2, 3, 2, 1, 1. 1, 2, 3, 2, 1. 1, 2, 3, 2, 1. 1, 2, 3, 2, 1. The moment I have a 1, 2, everything else will repeat. A 1, 2 generates a 3, a 2, 3 generates a 2. A 3, 2 will generate a 1. A 2, 1 will generate a 1. So moment 2 elements repeat, everything will repeat after that. So this goes in cycles of 5. So x0, 1, 2, 3, 4, x5, 1, 2, 3, 4, x 2021, at least a remainder 1 on division by 5. It should be here, the second step of the cycle. It is 2. The mistake I did, I did all this. And then I said, cycles of 5, I assume that x2, so we're starting with x1, starting with x0. So something to be careful about in the last step also. We're starting with x0. So the answer is 2. Log of this whole thing to the base 2 minus 2 is 0. Or log of this whole thing to the base 2 is 2. Or 3 plus log to the base 3 of 4 plus log to the base 4 of x minus 1 is 4. 4 is 2 square. I'm taking this 2 that side and putting it as 2 square. I can take this 3 this side. 4 minus 3 equal to 1. I'll remove this log to the base 3 completely. Means there's remaining 4 plus log to the base 4 of x minus 1 is 3 power 1, which is 3. Or log of x minus 1 to the base 4 is minus 1. Or x minus 1 is 4 power minus 1, which is 1 by 4. Or x is 1 plus 1 by 4, which is 5 by 4. Also, t-tag question, but you ask for 4x. X is 5 by 4. 4x is 5. X square minus xy minus x is 22. And y square minus xy plus y is 34. X is greater than y. Let's do this. X square minus xy minus x is 22. Y square minus xy plus y is 34. X is greater than y, that much we know. Let's see if we can do something. Let's add these two. Let's see where that goes. So this is x square plus y square minus 2xy minus x plus y equals 56. X minus y whole square minus of x minus y is 56. X minus y into x minus y minus 1 is 56. Very nice. X minus y into x minus y minus 1. Two numbers differing by 1 is lesser. 8 into 7 is 56. or minus 7 into minus 8 is 56. Nicely done. We want to find x minus y. X is greater than y. That means x minus y is positive. So we cannot have minus 7 into minus 8. X minus y should be 8. 8 is there. The choice is done. Adding these two, it opens lock straight away. Three positive integers x, y, and z are in arithmetic progression. Very nice. If y minus x is greater than 2, x positive integers x, y, z equals 5 times x plus y plus z. X plus y plus z is 3y, middle term. It can be y minus d, y plus d, or x, y, z is 5 into 3y, or x into z is 15. It could be, hey, 3 into 5 or 1 into 15. We know y minus x is greater than 2. The common difference is more than 2. So z minus x should be more than 4. This is out. Or z is 15, x is 1, y is 8. Z minus x is 15 minus 1, which is 14. Yeah. Middle term into 3 is sum of 3 terms. This is an arithmetic progression. For all real values of x, the range of the function x square plus 2x plus 4 by 2x square plus 4x plus 9. X square plus 2x plus 4 is x plus 1 whole square plus 3. 2 times x square plus 2x x square plus 4x plus 9 by 2. Or think of this as 2 times x square plus 2x plus 1 plus 7. 7 by 2, taking 1 here and keeping the 7 that side. Or I can rewrite this expression as x plus 1 whole square plus 3 by 2 times x plus 1 whole square plus 7. And x plus 1 whole square plus 3 by 2 times x plus 1 whole square plus 7. Or x plus 1 whole square plus 3 2 times x plus 1 whole square plus 3 plus 1. Sorry. Plus 2. Sorry. 1 second. Plus 1. Right, so I'm writing the same numerator, replicating it in the denominator, and then plonking a plus 1 outside of it. Wonderful. So x plus 1 whole square plus 3, I'm going to call it as k. This is k by 2k plus 1, where k is x plus 1 whole square plus 3. Right, so wonderful. So minimum value k can take is 3. This is 3 by 7. If k is any more than 3, then this number will keep getting bigger and bigger. K by 2k plus 1. So by 100 by 2 into 100 plus 1. 1000 by 2 into 1000 plus 1. A million by 2 into million plus 1. This 1 loses significance slowly. Right? So this number, the larger its value, the most significant point will be when k is as small as possible. If k becomes larger and larger, the 1 starts to lose significance. So it becomes effectively 1 by 2. If you put k as a billion, billion by 2 billion plus 1 is half, practically half. And so this number will go to half when k is very high. What is the smallest value it can take? In k is 3 by 7. The smallest it can take is 3 by 7. The largest it can take is 1 by 2. It cannot quite be 1 by 2. This is the answer. Complete the square. Create the expression after completing the square. Replicate the numerator expression in the denominator as much as possible. Then attack this question. So this becomes k by 2k plus 1, where k is this equation. You can even divide this by k and say 1 by 2 plus 1 by k. Dividing this entire thing, numerator by k, denominator by k. So it effectively depends on 1 by k. If 1 by k is large, this fraction will be small. If 1 by k is small, this fraction will be large. So the smallest value k can take is 3. Put 3 there, we'll get the smallest value of the expression. Largest value it can take is infinity, or as close to infinity as possible, which case will be 1 by 2. It can be 3 by 7, it cannot be 1 by 2, 3 by 7 to 1 by 2. 2.25 less than or equal to 2 plus 2 power n plus 2 less than or equal to 202. For all the possible integers n satisfying this, the number of integer values of this. Let's first find n that satisfy this. 2.25 less than or equal to 2 plus 2 power n plus 2 less than or equal to 202. Remove this 2. 0.25 less than or equal to 2 power n plus 2 less than or equal to 202. 0.25 is 1 by 4, which is 2 power minus 2. This can be 2 power minus 2. 1 by 4 is 2 power minus 2, or n plus 2 could be minus 2, or n could be minus 4. Minus 4 plus 2 is minus 2. 2 power minus 2 is 0.25, that was. N could be minus 3. It could be minus 2, minus 1, 1, 2, 0, 1, 2, 3, 4, all of this. 2 power n plus 2 should be less than or equal to 202. 2 power 6 is 64. 2 power 7 is 128. 2 power 8 is 256. N plus 2 cannot be 8. N plus 2 could be 7, or n could go up to 5. Or satisfying this equation, n could be minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, all of that. Now let's look at this. 3 plus 3 power n plus 1. N going from minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5. You can go till 5. Obvious one, this will work, 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 this will work. 3 power minus 1 plus 1 is 3 power 0, that will also work. Minus 2 plus 1 is 3 power minus 1, which is 1 by 3, that will not be an integer. These won't work. 5 positive integers, 0 and minus 1. 6 values of n will work. Sorry, 7 values of work. 1, 2, 3, 4, 5, 0, minus 1. 7 different values. For real number x, the condition modulus of 3x minus 20 plus modulus of 3x minus 40 equal to 20. And wonderful. I'm going to first simplify this and say modulus of x minus 20 by 3 plus modulus of x minus 40 by 3 equal to 20 by 3. Divide by 3 throughout, make life simpler for ourselves. We're dealing with x. What are we going to do? We know that if you have 2 points P and Q, distance between them is modulus of P minus Q, which is nothing but modulus of Q minus P. Right? Or P and 9 is P and Q. Now we have 20 by 3 and 40 by 3. The distance between them should be 20 by 3. Let's think about this. I'm going to plonk 20 by 3 on the number line, 40 by 3 on the number line. Nice. Now x to this, x to that should add up to 20 by 3. This distance is 20 by 3. 40 by 3 minus 20 by 3. Or x has to be a point in between these two. If it is here, this distance plus this distance is 20 by 3. If it is here, this plus this will be way more than that. Our x is between 20 by 3 and 40 by 3. This is where x should lie. Right? So now let's come to the question. So 20 by 3 less than x less than 40 by 3. 6.67 less than x less than 13.33. Obviously that's not there in the choices. But the question says for a real number x necessarily holds if 6 less than x less than 11 won't work. Because if I point x equal to 6.1, it won't work. 7 less than x less than 12, this could work. 10 less than x less than 15 won't work. X could be 14.2, it won't work. 9 less than x less than 14 won't work. X could be 13.9, it won't work. This is a subset of this. Therefore, that will work. Choice B, B for more. One of the roots of the equation ax square minus bx plus c equal to 0 is 2 plus root 3. And the other root should be 2 minus root 3. A, B, C are rational numbers. A not equal to 0. B equal to C cube. Okay, sum of the roots is minus B by A. In this case, it's B by A, which is 4. Product of the roots is C by A, which is 2 plus root 3 into 2 minus root 3, which is 1, or C equal to A, B equal to 4A, and B equal to C cube, or 4A equal to A cube, or 4 is A square. A is plus or minus 2. We want to find modulus of A, which is 2. Done. If 2 plus root 3 is a root, the other root is 2 minus root 3. Roots come in conjugate pairs if you have rational numbers as coefficients. That's the first part. Ax square plus bx plus c equal to 0. Sum of the roots is minus b by a. Product of the roots is c by a. Done. Get through. For a sequence of real numbers x1, x2, x3 till xn, if x1 minus x2 plus x3 minus till all the way till here, n square plus 2n for all natural numbers n, then the sum x49 plus x50. All these questions, simple rule of thumb, find x1, find x2, find x3, get through. x1 should be 1 square plus 2 into 1, 1 plus 2, 3. x1 plus x2, or x1 minus x2, minus x2 is 2 square plus 2 into 2, which is 8. x1 minus x2 plus x3 is 3 square plus 2 into 3, which is 9 plus 6, 15. This thing minus x4 is 4 square plus 2 into 4, which is 16 plus 8, 24. Nice. x1 is 3, x1 minus x2 is 8. 3 minus x2 is 8, or x2 is minus 5. x1 minus x2 is 8. Add x3, we get to 15, or x3 is 7, x2 is minus 5, x1 is 3. From 15, we subtract x4 to get 24. 15 minus x4 is 24, or x4 is 15 minus 24, which is minus 9. Nice, we've got ourselves a beautiful pattern. 3 minus 5, 7 minus 9, 11 minus 13. Alternate plus and minus, just a series of odd numbers. Then we sum x49 plus x50 equals, very interesting, x49 plus x50. x1 plus x2 is minus 2. x3 plus x5 is minus 2. x3 plus x4 is minus 2. x5 plus x6 will be minus 2. Every pair of adjacent numbers that we're adding up will add up to minus 2. 3 minus 5 minus 2. 7 minus 9 minus 2. 11 minus 13 minus 2. So we keep on adding and getting the total to be minus 2 for each chunk. So x49 plus x50 is also equal to minus 2. Done. Get the numbers, see the pattern, plonk in, get through. For a real number, if log a to the base 15 plus log a to the base 32 by log a to the base 15 into log a to the base 32 is 4. This is of the form a plus b by ab. I'm going to carve this out separately. 1 by log a to the base 32 plus 1 by log a to the base 15 is equal to 4. The first term by the whole denominator, second term by the whole denominator. The first time log a to the base 15 will get cancelled. Second time log a to the base 32 will get cancelled. 1 by log a to the base 32 is log 32 to the base a plus log 15 to the base a is 4. Nice. Or log of 32 into 15 to the base a is 4. Or a power 4 is 32 into 15, 480. A is 4th root of 480. Where should it lie? 4 power 4 is 16 square, 256. 5 power 4 is 625. 3 power 4 is 81. A is between two. A power 4 is between these two. A should lie between 4 and 5. 3x plus 2 mod y plus y equal to 7. X plus mod x plus 3y equal to 1. We want to find x plus 2y. First I said, look, can I add these two equations and get x plus 2y? Can I subtract one from the other and get x plus 2y? Tough, because there's a mod y here and a mod x here. They're not going to go away in a hurry. Right? So what do we have to do? One beautiful thing. So very simple idea. Mod a equal to a if a is greater than 0, equal to minus a is less than 0, equal to 0 when a is 0. And so we can use that idea. Then when x is positive, mod x will be x. When x is negative, mod x will be minus x. We can form different equations, then solve them. So we'll have to solve for x positive, y negative, x negative, y positive, both positive, both negative. We'll get 4 sets of simultaneous equations, solve them, and then the solution we get should satisfy this criteria. If it does, then we have an answer, then we can plug it. I said I have to solve the simultaneous equation 4 different variants. Now that is tricky, that's a pain in the neck. Maybe that's what they want us to do, which is fine, but then it's going to take time. One other thing that we can notice, x plus mod x, x plus mod x, x plus mod x, if we add x and mod x, it is going to be 0. X plus mod x will be 0 when x is negative. And so maybe there is something there. So what do? First of all, I'll put x as negative, that is these two, because then this goes to 0, and then see where that takes me. So if x is negative, this goes to 0, 3y is 1, y is 1 by 3. If y is 1 by 3, x is negative works, we are true. Let's go there to the first equation. 3x plus 2 mod y plus y is 7, y is 1 by 3. So 3x plus 2y plus y is 3y, y into 3 into 1 by 3 is 1, 7, 3x is 6, x is 2. This doesn't work. If we put x is negative, y is 1 by 3. If I put y is 1 by 3, I get x is 2. That doesn't work. So x is negative is not possible. Right? Now I have only 2 equations, both positive, both positive, x positive and y positive, x positive and y negative. Both positive, I'll have 3x plus 3y is 7 and 2x plus 3y is 1. I subtract 1 from the other, I'll get x is 6. If x is 6, 6 plus 6 is 12, 12 plus 3y is 1, 3y is minus 11, doesn't work. Y will have to be negative. X is positive, y is positive, does not yield any solution. X is negative, does not yield any solution. X positive, y negative. So we are looking for x positive, y negative. That is 3x minus 2y plus y is 7 and x plus 3y is 1. 3x minus y is 7, 2x plus 3y is 1. Multiply this by 3, 9x minus 3y is 21. Add these two, 11x is 22, x is 2. When we plug in x is 2, we should get y as negative. If we don't get y as negative, there's no solution. Done, game over. When x is 2, let's plug this in. 2 plus 2 is 4, plus 3y is 1. 3y is minus 3, y is minus 1. 2 comma minus 1 works. Then x plus 2y. 2 plus 2 into minus 1. 2 minus 2 is 0. This works. There is perhaps some juicy solution sitting here somewhere, but I don't know. We have brute force it. We get the answer. We roll with it. So consider a sequence of real numbers x1, x2, x3 such that xn plus 1 is xn plus n minus 1 for n, all n greater than or equal to 1. x1 is minus 1 and x100 equal to. Start with n greater than or equal to 1. So let's say xn equal to 1. So x2 equals x1 plus 1 minus 1. x3 equals x2 plus 2 minus 1. x4 equals x3 plus 3 minus 1. So x1 equals minus 1. x2 is x1 plus 0. So x1 is minus 1. x2 is also minus 1. x3 is x2 plus 1, which is 0. x4 is x3 plus 2, which is 2. x5 is x4 plus 3, which is 5. x6 is x5 plus 4, which is 9. x7 is x6 plus 5, which is 14, and so on. And there are two ways of doing this. One is to write this equation down and then say, hey, I'm going to write all the way till x100 equals x99 plus 99 minus 1 plus 98. Beautiful set of equations. And where if you add all of these equations and add all of them up, so then there's an x2 here, x2 here, x3 here, x3 here, x4, x4, all the way to x99, everything will get cancelled. We will get quite simply x100 to be equal to x1 plus 0 plus 1 plus 2 all the way till 98. We know how to do this, so we can plug that in. What is the other way? We can find a pattern in these numbers. That's brilliant as well. 2, 5, 9, 14, very interesting. If you add 1 to these numbers, 1, 3, 6, 10, 15, that's very interesting. This just sum up to one natural number, sum up to two natural numbers, sum up to three natural numbers, sum up to four natural numbers, sum up to five natural numbers. x7 is sum up to 5 natural numbers minus 1. x6 is sum up to 4 natural numbers minus 1. x100 would be sum up to 98 natural numbers minus 1. x100 would be sum up to 98 natural numbers plus x1, which is minus 1, or x100 is equal to 1 plus 2 plus 3 all the way till 98 minus 1. This we know. This is 98 into 99 by 2 minus 1. 99 into 49 minus 1. Whatever that number turns out to be. 9 9s are 81, 1 8, 9 4s are 36, 441, 441, 1 5 8, 4851 minus 1, which is 4850. Lovely, lovely, lovely question. I got this wrong a number of times, not just once, a number of times. I simply didn't grab onto the funda. This xn plus 1 equal to xn plus n minus 1, beautifully carved out. So be very careful with the detail. Make sure this is marks in the back. If you focus and get the detail right, it should be doable. The number of distinct pairs of integers m, n satisfying this inequality. Wonderful, wonderful question. I really struggled with this one. So first thing to know is mod a less than mod b is same as saying a square less than b square. One implies the other. That's the first step to do. That means we can say 1 plus mn the whole square is less than m plus n the whole square, or 1 square plus m square n square plus 2mn is less than m square plus n square plus 2mn. Nice, so far so good. This 2mn gets knocked off on both sides. 1 plus m square n square minus m square minus n square is less than 0, or 1 minus n square minus m square plus m square n square is less than 0. 1 minus n square minus m square times 1 minus n square is less than 0, or quite beautifully 1 minus m square into 1 minus n square is less than 0. Nice. We're looking at distinct pair of integers. Product of two numbers is less than 0. Either this is negative, this is positive, or the other way around. Right? So either this is negative and this is positive, or this is positive and this is negative. The beauty of this is 1 minus m square is negative. That is reasonable. Lots of numbers. 1 minus n square is positive. 1 square is 1. N can't be 1. It will become 0. 2, 3, 4, 5, it won't work. Only possibility where 1 minus n square is positive is when n equal to 0. Only positive possibility where 1 minus m square is negative is when m is 0. So m equal to 0, n greater than 1 works. If m or n were 1, this won't work, it will become 0. If m is 0, n greater than 1 works. Or n equals 0, m greater than 1 works. Nothing else is possible. If m and n are both more than 1, both will become negative, product will become positive. If either of them is 1, product will go to 0. That doesn't work. So one of them should be 0, other one should be greater than 1. So m0, n greater than 1, or n0, m greater than 1. That's a possibility. Now let's come back to this question. This is not n greater than 1. This is mod n greater than 1, mod m greater than 1. Because we're talking about n square. So plus 1 works and minus 1 work. Plus 2 works and minus 2 will work. Plus and minus 1 will not work. Plus 2 and minus 2 will work. Modulus of m plus n less than 5. This is an interesting thing. So let's attack that. Modulus of m plus n less than 5. If m is 0, mod n less than 5. When m is 0, mod n less than 5, n has to be greater than 1, be 2, 3, 4. N could be plus or minus 2, plus or minus 3, plus or minus 4. Exact opposite. If you put n equal to 0, we have mod m less than 5. We know mod m has to be more than 1. M could be plus or minus 2, plus or minus 3, plus or minus 4. So 0, 2, 0, minus 2, 0, 3, 0, minus 3, 0, 4, 0, minus 4. 6 possibilities, plus 6, 12 possibilities. Super tough question. Really tough question. So it's kind of question which says, okay, I'm not touching this. We square this, then we get somewhere. And still there's a couple of steps to go. And wonderfully tough question. F of x is x square minus 7x and g of x is x plus 3. Then the minimum value of f of g of x minus 3x. F of x plus 3 minus 3x. We need to minimize this. This is x plus 3 whole square minus 7 times x plus 3 minus 3x. Let's find this. X square plus 6x plus 9 minus 7x minus 21 minus 3x. This is x square. 6x minus 7x is minus x minus 4x minus 12. Simple completion of square. X square minus 4x plus 4. This is x square minus 4x plus 4 minus 4 minus 12. This is x minus 2 the whole square minus 16. We want to find the minimum possible value of x minus 2 whole square minus 16. That can happen when x minus 2 whole square goes to 0. The value will be minus 16. Complete the square. Think of it as a square plus a balancing term. We are through. Freebie. For natural numbers x, y and z, if xy plus yz is 19 and yz plus zx is 51, y into x plus z is 19 and z into x plus y is 51. We told very clearly that x, y and z are natural numbers. 19 can only be broken as 1 into 19 or 19 into 1. It cannot be 19 into 1. X plus z cannot be 1. X plus z is 19. Y is 1. Plug that in here. So z into x plus 1 is 51. This is not 51 into 1, x cannot be 0. Not 1 into 51, x is not 50, that we know. 3 into 17, 17 into 3, x plus z is 19. So x, z into x plus 1. This could be 17 into 2 plus 1. 17 plus 2 is 19, that works. You put z as 3, x equal to 16. Then x plus z is 19, 3 into 17 also works. So we could have a scenario where y is 1, x is 2, z is 17, or y is 1, x is 16, z is 3. So this is 17 into 3 or 3 into 17. Both ways it works. So it adds, it could be z is 17, x is 2 could work, or x is 16, z is 3 could work. Minimum possible value of x, y, z, multiply this is 48, this is 34. Product is lower in this case, which is 34. Lovely, done, through. Let a, b, c be non-zero real numbers such that p square less than 4ac. And f of x equal to ax square plus bx plus c. Beautiful. ax square plus bx plus c is f of x, and b square is less than 4ac. When b square is less than 4ac, that means no roots are there. Discriminant is less than 0. The set S consists of all integers m such that f of m is less than 0. Then the set S must necessarily be a beautiful question. Right? So I'm going to do this very differently and say let's draw the graph of this. So y-axis and x-axis. Ax square plus bx plus c is f of x. It will be a curve, right? It will be a parabola. It will be something like this. It could be here, it could be here, it could be here, it could be here, anywhere. And if it cuts the x-axis, then that means f of x goes to 0. That means if I put f of x is equal to 0, I have roots. There is some x for which y equal to 0, f of x equal to 0. But f of x cannot be 0 because this has no real roots. How do I know that? That is given. That means our beautiful looking parabola is got to be something that does not touch the x-axis. It's completely above the x-axis. Which means, if you think about it, what is the set of all integers such that f of m is less than 0? This is less than 0. Never. So set S should be an empty set. Except the curve could be like this, or quite brilliantly it could be like this. In which case, for all integers it will work, or for no integers it will work. So f of x is either always greater than 0 or is always less than 0. This can never go to 0. It's either always greater than 0 or always less than 0. That means if you put any set of all integers where it will be less than 0, it could be never. In this case, f of m will never be 0. Set of all integers where it goes to 0 is a null set. In this case, set of all integers where it goes to 0 is all possible integers. So set of all integers or the empty set, either the empty set or set of all integers. That's the right answer. Absolutely delightful question, especially if we can reframe this as a graph, as a diagram. If you know that A is negative, you have a curve like this. A is positive, you have a curve like this. Ax square plus bx plus c. If A is positive, then the curve is U-shaped. If A is negative, it's parabola shaped. It's umbrella shaped. Both cases it's a parabola. So it's like an umbrella, like an inverted U. It's a U. If specifically a curve like this has no roots, then this curve cannot touch the x-axis. That means it is either completely above the x-axis U-shaped or completely below the x-axis umbrella shaped or inverted U-shaped. So in this case it will be a null set, in this case it will be all sets. The largest real value of A for which the equation modulus of x plus a plus modulus of x minus 1 equal to 2 has an infinite number of solutions for x. Nice simple question. And so we have x here and 1 here. This is modulus of x minus 1. Modulus of x minus 1 is nothing but the distance between x and 1. We have an infinite number of solutions. Modulus of x minus 1 plus modulus of x plus a equal to 2. I want to think about x plus a, this, as modulus of x minus a. And so it will have infinite solutions. So if minus a were here, x could be here, put x equal to 2. And so now think about it. When will it have infinite solution? First of all, between 1 and minus a, the distance should be not 5 or 15 or 20. It should be small, right? Because this is modulus of x minus 1, this is modulus of x plus a. If minus a were 100, this distance itself is 99. It has infinite number of solutions. That gives us one beautiful getaway. It tells us that x should sit between 1 and minus a. We have 1 here, minus a here. This distance should be 2. X being anywhere here, this plus this will be 2. Or minus a could be here, this distance being 2. X being anywhere here, this distance plus this distance would be 2. And that is the kind of scenario we're looking for. Right? Otherwise, there will be a unique number of solutions, so values for which it will work. And an infinite number of solutions, they're basically saying we should be able to say x can be anywhere between 1 and a, and this will work. Anywhere between 1 and a, it will work. The distance will be 2. That means x is banged in between 1 and a. And the distance between 1 and a is 2. Sorry, not 1 and a, 1 and minus a. Or minus a could be 3, minus a could be minus 1. A is 1 or a is minus 3. Both of these will be possible. So we are either thinking x lies between 1 and 3 or thinking x lies between minus 1 and 1. So a is minus 3 or a is 1. Largest real value is 1. Minus 3 is not available. 1 works. So we're basically looking at a to be 2 units from 1. The distance between x and 1 is given. If 1 and a were 2 units apart, then x can be anywhere in between. This will hold good. We'll have an infinite number of solutions. And so the more algebraic way of doing it, saying I denote the turning points as minus a and plus 1. We know that mod x equal to x if x is greater than or equal to 0, to minus x if x is less than 0. We're basically saying I can say this x plus a plus x minus 1 equal to 2. That is one possibility. Where this is positive, this is positive. Or minus x minus a minus x plus 1 equal to 2. That both are negative. Or x plus a plus 1 minus x equal to 2. Or minus x minus a plus x minus 1 equal to 2. You solve for this, we get 2x equal to 3 minus a. We get 2 solutions. We get minus 2x equal to 1 plus a. We get 2 solutions. You solve for this, a plus 1 equal to 2, a is 1. You solve for this, we get minus a equal to 3, a is minus 3. If a were 1, if a were minus 3, any x will hold good here. That's what we are solving for. Therefore, a could be 1 or minus 3, largest value is 1. That's the algebraic brute force way of solving it. And again, a beautiful method, but the longer method works better. The visual method works better. For any real number x, let box of x be the largest integer less than or equal to x. If sigma n equal to 1 to n, sum of 1 by 5 plus n by 25 equal to 25, then n is. I understand these kind of questions, so I brute force them. What do? I put n equal to 3. Between box of 1 by 5 plus 1 by 25 plus 1 by 5 plus 2 by 25 plus 1 by 5 plus 3 by 25. This is 0, 0, 0. This will be 0. When will this fellow is the largest integer less than or equal to x? That is, this greatest integer of 0.99999 is 0. Of 1.00001 is 1. Greatest integer of 1 is 1. When does it become 1? 1 by 5 here, this should be 4 by 5. If n were 20, that's when it will go to 1. Or, if I put capital N equal to 20, 1 by 5 plus 1 by 25, 1 by 5 plus 2 by 25, 1 by 5 plus 3 by 25, all of them will be 0. 1 by 5 plus 20 by 25 will be 1. So if capital N were 20, this whole sigma thing, whatever this is, that will be 1. That's when it goes to 1. We want it to be 25. What will I do? So it will be more than 20. Maybe I'll use 21 also. And this is 1 by 5. 1 by 5 plus 20 by 25. Greatest integer of this is 1. 1 by 5 plus 21 by 25. Greatest integer will be 1. Why? Slightly more than 1. True. This is 1 by 5. This should become 2. So I'm going to solve for 1 by 5 plus x by 25 equal to 2. X by 25 should be 9 by 5. X should be 45. When x goes to 45, it will become 2. Till then, it will be 1. I put 25, 26, starting from 20, 20, 21, 22, 23, 24, 25, 26, 27, till 44 will be 1. So I suppose I put, therefore, now if I put capital N equal to 44, and I'm adding from n equal to 1 to 44. 1 to 19, there is nothing. 1 by 5 1 by 5 plus 20 by 25. 1 by 5 plus 21 by 25. All the way till 1 by 5 plus 44 by 25. All of these give us 1, 1, 1, 1, 1 each. How many terms are there? 25 terms are there. If I put 45 by 25, it will go to 2. If I put n equal to 45, from 45 onwards, 45, 46, 47, all the way till 69, it will be 2. We'll keep adding 2 to each sum. How many terms are there? 25 terms are there. Or when n equal to 44, the summation equal to 25, n is 44. Beautiful question. So how will this work? Suppose we had to do this as a function. We call this f of n. And so f of 1, f of 2, f of 3, all the way till f of 19 would be 0. F of 20 would be 1, f of 21 would be 2, f of 22 would be 3, f of 22 would be 4, f of 44 would be 25. F of 45 will become 27, 29, keep adding. When does it become 25? It becomes 25 and n is 44. Greatest integer function is a beautiful function. A square plus ab plus a is 14, b square plus ab plus b is 15. These questions are painful. The only thing that's giving my sanity here is a and b being natural numbers. That's very nice, beautiful to get. What do? We add both of these. Get a square plus 2ab plus b square plus a plus b is 42. Or a plus b whole square plus a plus b is 42. A plus b into a plus b plus 1 is 42. We put a plus b as x into x plus 1 is 42, or consecutive natural number 6 into 7 is 42. A plus b is 6. This cannot be 3 and 3 because then these two will give us the same answer. A appears to be smaller. This is a square and a, this is b square and b. It becomes double. So a appears to be smaller. That's all. Put a as 2. Put a as 2, b as 4. 2 square plus 2 into 4 plus 2. 4 plus 8 plus 2. 14. Yep, that works. A is 2, b is 4. That should work. So what is 2a plus b? 2 into 2, 4 plus 4, 8. If we add these two, we get a plus b is 6. 3, 3 doesn't work. 2, 4 should work. And then we are through. We can solve this. We can say a is 6 minus b, substitute that here, get that quadratic, solve and get a. That's the other more algebraic method. We can snap out of it and simplify this. For any natural number n, suppose the sum of the first n terms in arithmetic progression is n plus 2n square. If the nth term of the progression is divisible by 9, then the smallest possible value of n is n plus 2n square. What I'm going to do, sum up to n terms is n plus 2n square. What will I do? I'll find sum up to one term. This is 1 plus 2, which is 3. And sum up to two terms. 2 plus 2 into 2 is 4, 4 into 2 is 8, 2 plus 8 is 10. Sum up to three terms. 3 plus 2 into 9 is 18, this is 21. Sum up to four terms is 4 plus 2 into 16 is 32, this is 36. Or the first term is 3, second term is 10 minus 3 is 7, third term is 21 minus 10 11, fourth term is 15, and so on. Done. First term, sum up to one term, two term, subtract this minus this, that's the second term. This minus this, that's the third term. This minus this, that's the fourth term. So we've got our sequence. If the nth term of the progression is divisible by 9, the smallest possible value of n is 3, 7, 11, 15 didn't work, 19, 23, 27, this works, 1, 2, 3, 4, 5, 6, 7, 7th term works. Find S1, S2, S3, S4. With that we have found term 1, term 2, term 3, term 4. With that we know the AP. Write down the AP. One term is multiple of 9. Get through. F of x equal to modulus of x minus p modulus of plus modulus of x minus 100 plus modulus of x minus a minus 50. Distance between x and a, distance between x and 100, distance between x and a plus 50. The maximum value of f of x becomes 100 when a is equal to. Very nice. So let's put 0, a, x, 100. So first of all, the maximum value possible in this function, this is modulus of x minus a, this is modulus of x minus 100 or 100 minus x, either way it won't matter. And then modulus of x minus of a plus 50. A plus 50 we are subtracting x, or from x we are subtracting a plus 50. And so this is the function. F of x is modulus of x minus a plus modulus of 100 minus x plus modulus of x minus a minus 50. When will this be maximum? For a given a, right? For a given a, this is 100 minus a, will be maximum when x is 100, because x minus a minus 50 is remaining, or a plus 50 minus x is remaining, one of these two. And so a plus 50 could be so small that x minus a plus 50 is remaining, or a plus 50 is large but x is even larger. From x to a plus 50, that distance is remaining. That is the remaining distance that we need to calculate. Finally, we need to include distance between x and a plus 50. Nice. This is built in, always equal to 100 minus a. Maximum distance between x and a plus 50, that will be the maximum of 100 plus x. Distance between x and a plus 50 plus 100 minus a is equal to f of x. 100 minus a is this, and this adds up to 100 minus a, right? And distance between x comma a plus 50 plus 100 minus a is f of x. The maximum possible value of f of x becomes 100 when a is equal to. So maximum possible value of f of x becomes 100. So that means distance between x and a plus 50. Remember, a plus 50 could be higher than x, or x could be higher than a plus 50. And so when x is higher than a plus 50, the maximum value would be when x is 100. And so, and a plus 50 is some value. We find that out and come back. When a plus 50 is less than x, a plus 50 is this side, distance between x and a plus 50 is once again when x is 100. When a plus 50 is higher than x, when x is lesser and lesser. Right? That's when this happens. Now, the maximum distance between x and a plus 50, a and a plus 50 lies somewhere. X is more than a. If it is less than a plus 50, I put x at a. That's when that distance will be 50. That's the maximum I can have. Put x at a. Distance between x and a plus 50 can be as high as possible. X cannot go below a. So the maximum difference between x and a plus 50 is 50. That's the maximum possible. And so it cannot be more than 50. Because x cannot be less than a, that much we know. A and a plus 50 distance is 50. If x were greater than a plus 50, then we'll have 0, a plus 50, x. Then x and a plus 50 cannot have a distance of 50. Why? Because if a plus 50 were 50, x would be 100. That's not possible, because a plus 100 will be more than 100, because 0 less than or equal to a. So the maximum distance, this value maximum would be 50 when x is at a, and a to a plus 50 distance is 50. So this maximum is 50, or when the maximum goes to 100, 100 is equal to 50 plus 100 minus a. Or this maximum is when a is equal to 50. When we have a scenario where 0, 50, 100 and x is in between 50 and 100, in that case the maximum value of f of x will be 100 minus a plus x minus of a plus 50, in which case when x is 50, that's when the maximum will reach out to 100. Absolutely delightful question, super difficult, super tough. Right? So we have to reframe this modulus of P minus Q is the distance between P and Q on the number line. That's a funda. You grab onto that, bunch of these questions become that little bit more doable. And that's something that we should look to grab onto. On day 1, there are 100 particles in a laboratory experiment. On day n, where n is greater than or equal to 2, 1 out of every n particles produces another particle. The total number of particles in the lab experiment increases to 1000 on day 1, then day m, then m equals. Nice. This day 1, day 2, day 3, day 4, day m. And day 1, there are 100. What are the additions that happen? On day 2, 1 out of every 2 particles produces another particle. So on day 2, 100 to start with, half of 100 gets added. Half into 100. 50 get added. We'll have 150. Nice. What happens on day 3? We have 1 by 3, 1 by n, and n is 3, 1/3 of particles get added. What gets added? 1 by 3 into 150, which is 50. This becomes 200. Day 4, what gets added? 1 by 4th of 200, which is 50. This becomes 250. 1 by 5 of 250, 300. 1/6 of 300, 350, and so on. Or, quite simply, every day 50 particles get added. We start with 100. Somewhere down the line, we're going to hit 1000. 50, 50, 50, we keep adding every day. We have to add 900, or we add for 18 days. Number of times we add is 900 by 50. 50 added each day. 900 is 1000 minus 100. We started with 100, we need to add 900. 900 by 50 is 18. 18 times we add. On day 1, we have 100. Day 2, we add 50. Day 3, we add 50. 18 days we add. Our total number of days is 19. Very nice, juicy question. This description part is tricky, but otherwise the question is very simple. A lot of these questions put day 1, day 2, day 3, day 4, track, see, visualize, then we can simplify. The average of a non-decreasing sequence of n numbers, a1, a2, a3 till an is 300. If a1 is replaced by 6a1, the new average becomes 400. And the number of possible values of a1 is a nice, beautiful question. A non-decreasing sequence. What does it mean? It means a1 is less than or equal to a2, less than or equal to a3, less than or equal to a4, all the way to an. Something to keep in mind. We know that a1 plus a2 till an divided by n is 300. a1 is replaced by 6a1. 6a1 plus a2 till an divided by n, average will be higher, average is 400. Nice, excellent. Or a1 plus a2 till an is 300n. We'll rewrite it like this. Remove this, say hey, this is 300 times n. Say this is 400n. Or if we subtract one from the other, we have 5a1 equals 100n, or a1 is 20 times n. Nice, brilliant. Now is where this question gets interesting. This part kicks in. a1 is 20n. a2 should be greater than or equal to 20n. a3 should be greater than or equal to 20n. Each of these entities is at least 20n. The smallest they can be is 20n. Right? And we know a1 plus a2, a3 till an is equal to 300n. Each of them is at least 20. Should be adding up to 300. We put all of them as 20. It's a minimum possible scenario. In that situation, adding up to 300, let's find what value n can take. Or we say 20n into n. All of them are equal. We get to 300n. Or n is 30 by 250. If n were 15, then each of the quantities could be 20n. And adding all of them up, we'll get 300n. Brilliant. That means if n were 16, a1 being 20n, get even 20, 20, 20, 20, 16, 20n. It's an extreme scenario. If you still add up to 320n, that's not possible. The maximum value n can take is 15. So n is a maximum value n can take. N is 15, we can find a1. a1 is 15 into n. We can find that. Can n be 14? Yeah, n can be 14. a1 would be 280. 14 into 20, 280. Adding the first 14 terms would be, average would be 300. Sum would be 300 into 14. We can find different combinations, it will work. N can be 14, 13, 12, all the way till 3, 2, 1. Just want to check the extreme condition, n equal to 1. If n were 1, there's only one term, then a1 is 300. 6a1 equal to 400. This is not possible. This doesn't work. So n cannot be 1. But everything else will work. N equal to 2. a1 plus a2 is 600. a1 is 2 into 15, which is 30. a2 can be the remaining, this will work. Nothing wrong. So this can work. So a1 plus a2 being 600, n equal to 2 will work. From 15 all the way till 2 will work. 14 different values. N equal to 1 will not work. That doesn't work. So 14 different values. Absolutely beautiful question. Brilliant question. Let r and c be real numbers. If r and minus r are roots of 5x cubed plus cx square minus 10x plus 9 equal to 0, then c equals. Nice question. 5x cubed plus cx square minus 10x plus 9 equal to 0. Then the roots are r and minus r. Let the third root, the three roots, a cubic equation, the third root be p. Sum of the roots will be r plus minus r plus p equals minus c by 5. Minus of this by 5. Product of the roots taken 2 at a time, which is r into minus r plus rp minus rp equals minus 10 by 5 minus 2. Product of the roots r into minus r into p equals minus plus minus 9 by 5. Using these three equations, we should be able to find a value for c. Some of the roots taken 2 at a time, 3 at a time. So r plus minus r is 0, p is minus c by 5. rp minus rp is 0, minus r square equals minus 2, r square equals 2, r is root 2. Here we have minus r square into p equals minus 9 by 5. Cancel off the minus, r square is 2, 2p equals 9 by 5, p is 9 by 10. We know p is minus c by 5, 9 by 10 equals minus c by 5, or c equals minus 9 by 2. Nothing, no rocket science here. To manage the equations, manage some algebra, be comfortable with r minus r and p, some of the roots, product of the roots taken some of the roots taken multiplying 2 at a time, 3 at a time. Be careful with minuses and pluses, then we are through. Suppose for all integers x, there are two functions f and g such that f of x plus f of x minus 1 equal to 0, and g of x equal to x square. If f of x square minus x equal to 5, the value of f of g of 5 plus g of f of 5 is. Tough question. Let's simplify this. All integers x. So f of x plus f of x minus 1 equal to 1. That's what this is. G of x equal to x square, that is very easy. Nice. So I'm going to write a few equations. F of 2 plus f of 1 equals 1. F of 3 plus f of 2 equal to 1. F of 4 plus f of 3 equal to 1, and so on. F of 2 plus f of 1 is f of 3 plus f of 2. Both of them have f of 2. Both are equal to 1, or f of 1 should be equal to f of 3. Both of these have f of 3, f of 2 should be equal to f of 4. Beautiful. F of 2 plus f of 1 is nothing but f of 2 plus f of 3. Both are 1. This plus this equals this plus this. F of 2 is common, or f of 1 is equal to f of 3. Between these two, f of 3 is common, f of 2 is equal to f of 4. Or we just extrapolate it beautifully. We'll get a wonderful equation, which is f of 1 equal to f of 3 equal to f of 5 equal to f of 7 equal to f of 9 and so on. Exactly same approach. We have f of 2 equal to f of 4 equal to f of 6 equal to f of 8 and so on. All even numbers, f of that will be same. All odd numbers, f of that will be same. Nice. We have f of x square minus x equal to 5. What am I going to do? I'm going to put x equal to 1. F of 1 square minus 1 equal to 5. F of 0 is 5. F of 2 square minus 2 is equal to 5. F of 2 is 5. 3 square minus 3 is f of 6, that is 5, or all even numbers. F of all even numbers is 5. So one part of the equation we have got all of these fellows are equal to 5. Nice. Now let's say this. F of 2 plus f of 1 is 1. F of 2 plus f of 1 is 1. This is 5. 5 plus f of 1 is 1. Or f of 1 is minus 4. Or we have a brilliant equation. F of even integer is 5. F of odd integer is minus 4. Brilliant. Now what do we need to find? We know g of x equal to x square. That is nice and comfortable. We want to find f of g of 5 and g of f of 5. F of g of 5 is f of 25. We want to find f of 25 plus g of f of 5. F of 25 is an even number. 25 is an odd number. F of 25 is minus 4. G of f of 5. F of 5 is an odd number. F of 5 is an odd number. So f of 5 will be minus 4. It is g of minus 4, which is minus 4 whole square. So it is minus 4 plus 16, which is 12. F of 25 is minus 4, f of 5 is also minus 4, both odd numbers. And so we know f of 25 is minus 4. G of f of 5 is g of minus 4, which is x square, minus 4 the whole square, 16, minus 4 plus 16. Beautiful question, delightful question. Not heavy duty function theory algebraically, but tons of common sense and very comfortable with putting numbers and playing with them and writing equations. That basic comfort level with writing this and then drawing this link and then saying, hey, all odd numbers are same, all even numbers are same. That is super important. The number of distinct integer values of n satisfying this is, and so this by this should be less than 0. Right? That means you could have a scenario where it is positive by negative or negative by positive. Nice. So what am I going to do? I'm going to think about when does this become positive and negative? When does this become positive and negative? I'm going to solve for 4 minus log n to the base 2 greater than 0. Okay. Or log n to the base 2 is less than 4. 2 power 4 is 16, n less than 16. N is less than 16, this is positive. N is equal to 16, this is 0. N greater than 16, this is negative. Same funda, this one. 3 minus log n to the base 4 greater than 0. Log n to the base 4 is less than 3. N less than 4 cube, 64. And so, if n is less than 16, this is positive. If n is less than 64, this is positive. So, I'm going to break our world into 3 parts. Less than 16, 16 to 64, greater than 64. Nice. Less than 16, this is positive by positive. Greater than 64 will be negative by negative. This is negative, this is definitely negative. What happens at 16? At 16, this goes to 0. What happens at 64? At 64, this goes to infinity or undefined. So it is less than 0. So I'm worrying about 16 to 64. In this case, the denominator is positive, numerator is negative. This is the range we are looking for. 64 to 16, but without counting 16, without counting 64. Or 17, 18, 19, 20, 21, all the way to 63. The first 63 natural numbers, subtract the first 16, 47. 17 to 63, all the numbers included. 17, 18, 19, 20, 21, all the way to 63. Break it down to the three regions. Think about negative by positive, positive by negative. Here it is both positive, here it is both negative. In between it works for us. That's the first step. Then be careful about, hey, am I counting 16? Am I counting 64? Is it less than 0 or less than or equal to 0? I'll be a little careful with doing the math. Then you're through. All numbers from 16 to 64 or between 16 and 64 without counting 16, without counting 64. The number of integer solutions of the equation x square minus 10 whole part x square minus 3x minus 10 equal to 1 is a very beautiful question. First of all, something power 0 is 1. 1 power anything is 1. So what do we now need to do? We have to solve for this going to 1 or this going to 0. Get those values, substitute in the other part, and then see if it is logical, whether it makes sense. And so what I'm going to do, I'm going to solve two different equations. I'm going to say x square minus 3x minus 10 equal to 0. Get the answers. I'm going to find x square minus 10 equal to 1 and get the answers. And then think about simplifying this. Nice. So x square minus 3x minus 10 is 0, or x minus 5 into x plus 2 equal to 0. X is 5 or x is minus 2. If it are 5 square minus 10 whole power 0, that will be 1. If it are minus 2 square is 4 minus 10 minus 6 power 0, that is 1. So 5 works, minus 2 works. Nice, brilliant. 1 power anything is 1. That is super interesting. So we'll say x square minus 10 is 1, x square is 11, x is plus or minus root 11. The two possible values, this could be root 11, in which case that would be some irrational thing. Do we need to worry about it? I don't need to worry about it at all, because in this case, we talk about integer solutions. X equal to plus root 11 minus root 11 simply doesn't work. If something per something is 1, either this base should be 1 or that number there should be 0. Put base equal to 1, solve. The exponent should be 0, solve, we are through. Have I completed everything? No, I have not. There's one more possibility here, which is minus 1 square is 1, minus 1 power 4 is 1, minus 1 power an even number is 1. So there is a possibility of that happening, in which case I'll have to verify that. So I'm going to solve for x square minus 10 equal to minus 1, or x square equal to plus 10 minus 1, which is 9. That means x is equal to plus or minus 3. I got this far, but I cannot be sure that this will work, because for plus 3 and minus 3, my exponent should be an integer. More than that, it should be an even number. If it's an even number, then I am happy. But minus 1 power 101 will be minus 1. Minus 1 power 94 will be plus 1. So to substitute x equal to plus 3 minus 3, I have to verify whether it turns out to be an even number. Let's do that. This is x minus 5 into x plus 2. I put 3 minus 5 into 3 plus 2, which is minus 2 into 5, which is minus 10. Yeah, that works. I put minus 3 minus 5 into minus 3 plus 2, minus 8 into minus 1 equal to 8. This also works. Both are even numbers, both work. Therefore, x could be 3 or minus 3. We already got that x could be 5 or minus 2. So we have 5, minus 2, 3, minus 3. For 3 and minus 3, this goes to minus 1. That's an even number. We are very happy. For 5 and minus 2, this goes to some number that goes to 0. We are happy. 4 different values are possible. Beautiful question. Consider the arithmetic progression 3, 7, 11, 15, 19, etc. plus 4 plus 4 plus 4. And let a n denote the sum of the first n terms of this progression. Then the value of 1 by 25 summation times n equal to 1 to 25 times a n is. Very nice. We'll do the brute force method. So the progression is 3, 7, 11, 15. First term is, first term is 3, common difference is 4. Sum up to n terms is n by 2 times 2a plus n minus 1 into d. This is n by 2 times 2 into 3, 6 plus n minus 1 times 4. This is 4n minus 4, n by 2 times 6 plus 4n minus 4. 4n, this becomes 4n plus 2. This is n by 2 times 4n plus 2 or n times 2n plus 1. When n is 1, this is 1 into 3, 3, yeah. When n is 2, this is 2 into 5, 10, yeah, that works. Or an is n times 2n plus 1. We want to do sigma an and then do a 1 by 25 of it. 1 to 25 times, then divide by 25. So what do? I do summation an of 2n square plus n. 2 times sigma n square plus sigma n. 2 times n into n plus 1 into 2n plus 1 by 6 plus n into n plus 1 by 2. Into this I substitute n equal to 25 and then divide by 25. We have a 1 by 25 outside. Or this is just n. I'm going to do for 1 to 25. Or put n equal to 25 and do a 1 by 25. N is 25. So cancel 125 completely. 2 by 6 is 1 by 3. N plus 1 into 2n plus 1 by 3 plus n plus 1 by 2. Where n is 25, 26 into 51 by 3 plus 26 by 2. This is 13. 26 into 17, 17 6 are 102, 210, 17 into 2 is 34 plus 10, 44, 442 plus 13, which is 455. Just pure unadulterated raw brute force. I tried to do it by more elegant method. I didn't go anywhere. I didn't get anywhere. I thought I'll do 3 plus 7, 3 plus 7 plus 11, 3 plus 7 plus 11 plus 15, all of that. So I do sigma 1 to 25 an. My first term gets added 25 times, second term gets added 24 times, third term gets added 23 times, all the way to the 25th term, which just gets added 1 time. And then I divide by 25. I didn't go anywhere. I didn't get anywhere with that. I decided, look, I'm not doing any cute thing. Brute force it, get to the answer. F of x be a quadratic polynomial in x such that f of x is greater than or equal to 0 for all real numbers. And so, nice. So f of x is greater than or equal to 0 for all real numbers. Like something like this, curve like this. Right? So a curve that is completely above the x-axis, where it doesn't touch the, because if f of x were 0 for some number, it will touch the x-axis. It will cut the x-axis. Wherever it goes to 0, it will cut the x-axis at those points. This is a graph like this. F of 2 equal to 0. Okay, f of 2 is equal to 0 and f of 4 is equal to 6. So f of 2 is equal to 0. What does that mean? I remove this. And I say, okay, this is not flying above the x-axis. It is touching the x-axis. F of at 2, it goes to 0. Right? Or this has two roots, both at 2. This cuts off at 2. Or this is of the form x minus 2 whole square. It's a curve x minus 2 whole square. Now, f of 4 is 6. I thought it was x minus 2 whole square. I was very happy. I got f of 4 equal to 6. F of 4 is 2 minus 2 whole square, which is 4. It's not 6. And I said, look, it's not x minus 2 whole square. This is a curve which is k times x minus 2 whole square. it cuts at 2, it touches at 2. So there's two real roots, both at 2. This is from x minus 2 into x minus 2 whole square. Not just x minus 2 whole square, k times x minus 2 whole square. Right? That is this curve. Nice. F of 4 is 6. So k times 4 minus 2 whole square is 6. K times 4 is 6. K is 6 by 4, which is 3 by 2. Or our curve f of x is 3 by 2 times x minus 2 whole square. This will have f of x greater than or equal to 0 for all real values. This will have f of 2 equal to 0. This will have f of 4 equal to 6. Everything gets satisfied. F of minus 2 is equal to, so it's 3 by 2 times minus 2 the whole square minus 4 square, 3 by 2 into 16, 3 into 8, 24. The understanding of what that means, that f of x is greater than 0, that means flying above the x-axis. F of x is greater than or equal to 0, it could be flying or touching. It does completely greater than or equal to 0, but with one point equal to 0. That means it has real and equal roots, both roots being 2. It is of the form x minus 2 whole square. What do I mean of the form x minus 2 whole square? K times x minus 2 whole square. I wrote this down as x minus 2 whole square and I was like, this doesn't work. Like, no, it is a multiple of x minus 2. Suppose k is any integer such that the equation 2x square plus kx plus 5 equal to 0 has no real roots, and the equation x square plus k minus 5x plus 1 equal to 0 has two distinct real roots for x. Then the number of possible values of k is, the first one discriminant should be less than 0, second one discriminant should be greater than 0, not even greater or equal to. When we attack it, for the first one it is k square minus 4 into 2 into 5 is less than 0. That is k square is less than 40. So we're talking about 36 is the perfect square. We're talking about integers. So k goes from minus 6 to plus 6. We have 13 values with us here. Most likely 13 is not the answer because we've got one more condition here. And the equation x square minus plus k minus 5x plus 1 is equal to has two distinct real roots. So k minus 5 the whole square is greater than 4. It's not even greater than or equal to 4, it is greater than 4. B square minus 4ac is greater than 0. And so k minus 5 the whole square is greater than 4. What values could this be? We have to simplify this. I think we can even substitute from there and then try it out. K minus 5 whole square, or k minus 5 should be greater than 2, or k minus 5 is less than minus 2. K less than minus 2 plus 5 less than 3, or k greater than 7. K greater than 7 won't work. K less than 3 will work. K equal to 3 won't work. So we're talking about from 2 downwards the whole thing will work. Talking about 2, 1, 0 and then minus 1 to minus 6. Minus 6 to minus 1, 6 values. 0, 1, 2, all of them work. You put k equal to 0, 0 minus 5 the whole square, yeah, 1, 2, yeah, it works. So 9 values here, we're done. Discriminant greater than 0, discriminant less than 0, discriminant greater than 0. Simplify, we are through. Just integer solution, that's something we need to be careful about. The minimum possible value of x square minus 6x plus 10 by 3 minus x for x less than 3. Very, very nice question. This is not factorizable. Something is not factorizable. Factorizing is trick 1 in quadratic equation. Trick 2. Immediately after that is the idea of completion of squares. I'm going to write that number as x square minus 6x plus 9 plus 1 by 3 minus x. This is x minus 3 whole square plus 1 by 3 minus x. X minus 3 whole square, 3 minus x whole square, both are same. And so this is 3 minus x the whole square plus 1 by 3 minus x. We told very clearly that x is less than 3. So we can say x minus or 3 minus x is greater than 0. We can say 3 minus x equal to k. This becomes k square plus 1 by k, or k plus 1 by k. K plus 1 by k is either greater than or equal to 2 or less than or equal to minus 2. It cannot be less than or equal to minus 2 because we know x is less than 3, k is positive. And k is positive, so the minimum possible value is 2, done, through. We can rewrite this like this and then rejig this like this, we are through. let r be a real number and f of x equal to 2x minus r if x is greater than or equal to r, and r if x is less than r. Very interesting. Equation f of x equal to f of x holds for all real values of x where blah 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 blah. And so let's do this. R be a real number, f of x equal to r if x is less than r. Let's say if this is r, so the graph will be x, f of x equal to r till here equal to 2x minus r. So at r it will become r. After that it keeps increasing. This is a graph like this. This is f of x. Nice. F of x equal to f of x holds good for all real values of x where x is less than or equal to r, x is greater than or equal to r, x is greater than r. So I'm worried about this because whenever f becomes greater than r, I'm in trouble. And so I don't really like this because if I put f of phi r, f of x equal to 2x minus r, 2 into phi r minus r, 10r minus r, 8r. F of 8r, 16r minus r is 15r. After this, f of x starts flying, becomes more and more. And so greater than or equal to r, greater than r, I don't like these two. F of x will not be equal to f of x. F of phi r is large. F of large as in f of phi r is 8r. 2 into phi r minus r. 2 into phi r minus r is 9r. Sorry. F of 9r is 2 into 9, 18 minus 1, 17r. It will keep becoming bigger. So at r, f of r is equal to r. That I know. F of r is equal to r. And so f of any number less than that, f of r by 2 is r. F of r is r. So I know that this won't work, this won't work. This work. X not equal to r doesn't work because greater than r doesn't work at all. It starts flying away. So this work, the diagram is super useful. Imagining it diagrammatically is super useful. Greater than r doesn't work. It starts flying away. So we come back and simplify it. Square root of 7 by 5 whole power 3x minus 5 is equal to 875 by 2401. 4a by b power 6x minus y equals 2a by b power y minus 6x. Seems like a rather tough question, but it's actually not. And so 4a by b for all non-zero real values of a and b. And so this, I know 2401 is a power of 7. That really helps. 49 square is 2401. So this is 7 power 4. And I was looking for this being a power of 5, which it was not. But 875 I know is 1000 into 7 by 8. And so this number can be written as 125 into 7 by 7 power 4. Or this is 5 by 7 whole cube is equal to 7 by 5 whole power 3x minus y by 2, square root of 7 by 5. And so this is 5 by 7 whole cube, this is 7 by 5 power this. So this number is 7 by 5 power minus 1 is 5 by 7. 7 by 5 power minus 2 is 5 by 7 whole square. So this becomes minus of this. And it should become equal to this. So I can rewrite this as, this is 5 by 7 whole power y minus 3x by 2 minus of that is equal to 5 by 7 whole cube. Beautiful question because you have to crack that thing. Or y minus 3x by 2 is this, y minus 3x is equal to 6. Y minus 3x by 2 is equal to this. This question I got confused because there's a 4a by b here and a 2a by b here. But this says for all non-zero real values of a and b, for all values is equal, or this should be 0, this should be 0. Both should go to 0. Therefore, anything power 0 is anything power 0. It goes to 1, doesn't work. It goes to 2, it doesn't work. For all values of non-zero values of a and b, so there's going to be an a and b remaining. Even if I put a and b to in some form the power to be equal, there's a 4 and 2 remaining. The only thing that will work is 0. 6x minus y should be equal to y minus 6x equal to 0, or y is equal to 6x. 6x minus 3x is equal to 6. 3x is 6, x is 2, y is 12. X equal to 2, y equal to 12 satisfies all of this. value of x plus y is 2 plus 12, 14. If 3 plus 2 root 2 is a root of the equation ax square plus bx plus c equal to 0, and 4 plus 2 root 3 is a root of the equation ay square plus my plus n equal to 0, where a, b, c, m, n are integers, then what is the value of this? Fine. Very simple. If 3 plus 2 root 2 is a root, then the other root is 3 minus 2 root 2, and the conjugate pair. If 4 plus 2 root 3 is a root, 4 minus 2 root 3 is a root. What is the sum of the roots? The first one, the roots are 3 plus 2 root 2 and 3 minus 2 root 2. So minus b by a is equal to 6. Right. What is the product of the roots? Product of the roots is c by a. 3 plus 2 root 2 into 3 minus root 2 root 2. 3 square minus 2 root 2 square. 3 square is 9, 2 root 2 square is 8. 9 minus 8 is 1. Second one, the roots are 4 plus 2 root 3 and 4 minus 2 root 3. Sum of the roots is minus m by a. This is 4 plus 4, 8. Product of the roots is n by a. 4 into 4 is 16 minus 2 root 3 into 2 root 3. 2 square into 3, 12. 16 minus 12 is 4. Nice. We need to do b by m. So what is b? B is, everything can be written in terms of a. B is minus 6a. C equals a. M is minus 8a. And n is 4a. b by m is minus 6a by minus 8a, which is nice, which is 3 by 4, plus c minus 2b, which is a minus minus 6a, divided by n, which is 4a, minus 2b, a minus 2 into minus 6a, minus 6a into 2. Let me make it very clear, there's some ambiguity here, minus 6a into 2. Lovely. This is 3 by 4. A minus minus 12a is a plus 12a, 13 by 4. So 3 by 4 plus 13 by 4. This is 3 by 4, that is 13 by 4. 3 by 4 plus 13 by 4 is 16 by 4, which is 4. It all worked out rather well for us. Thank you. Nothing but the understanding that roots come in conjugate pairs, and the idea that sum of the roots is minus b by a, product of the roots is c by a. Plonk it in, you're through. Is it like this? 16x by y, 16x by y plus 49y by x. We rewrite this like this. Let's say x by y is k, then y by x is 1 by k. So this number is 16k plus 49 by k. Fine, so nice, wonderful. So I can say 16k plus 49k by 2 is greater than or equal to square root of 16k into 49 by k. Arithmetic mean of these two is greater than or equal to geometric mean of that. Or subtract that and make it a perfect square and then simplify that. And so this is assuming k is positive. If k were negative, it will be correspondingly the other way around, going down. And so 16k plus 49k by 2 is greater than or equal to this. Cancel this. This is 4, that is 7, greater than or equal to 28. 16k plus 49 by k is greater than or equal to 56. Or 16k plus 49 by k less than or equal to minus 56. If k were negative, I can establish this. Right, so it's either greater than or equal to 56 or less than or equal to minus 56. So greater than or equal to 56, this is possible. Less than or equal to minus 56, this is possible, this is possible. This here is not possible. So I have a scenario where 16k plus 49k by 2 is greater than or equal to square root of AB, then simplify it accordingly. And so very much like everybody knows this rule, which is say y plus 1 by y is greater than or equal to 2 or less than or equal to minus 2. This is very much like that. Very much like that, just to slightly change numbers, nothing more than that. And so 16x by y, 49y by x, very much we're writing it as 16k plus 49 by k greater than or equal to 56, less than or equal to minus 56. That's what we're doing. And so simplifying it like that, rewriting it, rejigging it like that. The average of all 3-digit terms in the arithmetic progression 38, 55, 72, etc., etc., etc. Plus 17, plus 17, plus 17. I'm going to call this as 34 plus 4, 55 plus 4, 72 plus, 68 plus 4, 102 plus 4 will be our first term. So how do we find our last term? We take 999 divided by 17, see what is remaining. It goes 5 times 85, 149. Can it go 9 times? No, it cannot. It will go 8 times, 136. Remaining is 13. So that is 17 into 58 is 986. We've got that much. So the last term here is going to be 986 plus 4. The first term is 106. The last term is 990. You have a bunch of terms in between. How many terms are there in between? We can find that this is 58th term. This is 17 into 6. 58 minus 5 is 53 terms are there. To be honest, we don't need all of that because we want to find only the average of this term. Sum of all of these terms are going to be n by 2 into first term plus last term. Average of all of this is going to be n by 2, the first term plus last term, divided by n. I don't need to find n. It's first term plus last term by 2. Average of first term and last term is average of all the terms. And so the exam, I looked at this question and said, look, I want to do a sum of all terms, and I found out this big gigantic number. I could have just simplified it and bypassed it. So our answer is 990 plus 106 by 2. 990 plus 106, 1096, which is 548. Piece of cake. We know the first term, we know the last term. Sum of the first and last term divided by 2 is average of all n terms. That's all we need to find.